Father and our God, we come before the throne of mercy this morning, giving thanks to you, Lord, for the 5 taken us, Jehovah, Lord, and even giving us life this morning, Lord. Thank you for the past 2 days in our conference on food and security, Lord. You've seen us through, Lord. And we pray for this new day you've given us, Lord, that it will be successful, God of glory, and whatever we go through, Jehovah, Lord, in our deliberations, in our presentations, King of Kings, may we glorify your holy name and help us to disseminate this knowledge on food and security to our level best. For the glory of your holy name, we pray this in Jesus' name. Amen.
I want to welcome all of us this day to our first session. And our keynote presenter this morning is Dr. Stephen Barasa. Dr. Stephen Barasa did his PhD in biological and organic chemistry in 2009 from University of Manchester under the supervision of John Cardinal. Dr. Stephen Barasa, it states his title, and it's just selective and cymatic decentralization approaches to synthesis or bioactive at cycle, an approach from quaternary to nitro 1, nitro 3 propendiols. Thereafter, he became a doctoral fellow at Visa Sandwich, UK. His work was on medicinal chemistry of neglected tropical diseases, but at the same time, he gained lots of valuable experience in discovery, chemistry, and drug discovery in general. Between 2013 and 2015, he was employed with biological chemistry department at Northern State Research UK as a chemist. His research interests currently are in computational drug discovery. Some of the projects he's involved currently include leveraging African medicinal plants and computer-aided discovery of drug leads against SARS-CoV-2, the viral causative agent of COVID-19. He's also involved in the interplay of artificial intelligence and ethnobiomedicine in the drug discovery campaign against cancers prevalent in Kenya. All of us, I want to ask that we usher in Dr. Stephen Barasa, who will take us through this morning session. So let's welcome Stephen Barasa, maybe by a clap of hands. Welcome, Dr. Stephen Barasa.
Thank you, Mr. Market. Can you hear me? Am I audible?
Yes.
Is my screen clear? Please confirm. Hello. So my topic today is on the ABC of COVID-19, which is the agriculture, biology, and chemistry of COVID-19. And this work, we did it together with Professor Kenga, who we worked together in the same research group. So it is ABC as in ABC. We want to make it easy, but now we want to integrate agriculture, biology, and chemistry. These are, and just try to make it easy for everyone. So, I mean, on my first slide, it's like...
Dr. Barasa, sorry, can we see your video?
Yeah, can you? Oh, okay, just a moment. You like to see my video? All right. How do we do that? What is happening? You like to see the video of my face or my screen? What are you saying, Dr. Kiplagat? Hello?
Your video on?
Okay. Let me just...
Dr. Barasa, you can continue.
Is that better? Dr.
Okay,
Kiplagat,
okay.
are we okay? Okay, all right. So can I turn on can I share my screen? Hello?
Continue.
Can you see my screen? Are you able to see my screen?
Just share your presentation.
Okay, I'm trying to get that. Oh, share screen. Share. Is that better? Is my screen sharing?
Yes, continue.
All right, so okay, that's fine. That is fine. So as I said, the advent of COVID-19 was more like a movie. If you can think of Days of Our Lives, that's a TV series. Everybody is able to tell. Everybody is able to give a story or narrate a narrative where he was, what was going on. We can all write a novel over that period of time. It was more like a whirlwind. We didn't know where the storm is coming from. And the storm was hitting us from all sides, left, center, and right. But having said that, Kenya, we are lucky that it was in the eye of the storm. By the eye of the storm, I mean that we didn't have rampant deaths and casualties. Although we had some casualties, but we compared to places like Italy, like America, like India, we were not at the center of the storm. We were not in the eye of the storm. But that, nevertheless, that didn't give us any certainty, because we didn't know or what was going to happen the following day, or the week after, or the month after, because of the variants of the different variants of COVID-19, and because of lack of information, and because it was a new situation, it was a new occurrence, it was a new it was new. So, but amidst all that, we had to take care of our lives to make sure that we are healthy and we don't succumb, and also we had to take care of our livelihoods, which is our jobs, our businesses. We had to also take care of our education and things like that. So it was a form of a Venn diagram. I mean, this a Venn diagram is whereby you're able to you need to make choices and selections very, very carefully to find that sweet spot that meets you, or that fits your situation. So it was a tight situation for everyone, and a lot of uncertainty. So, and amidst that, I mean, what came, the long and short of that is that we were all in a vicious cycle of being kicked left, right, and center. We didn't know what was coming to hit us next. So in order to break that vicious cycle, and in order to regain firm ground, we had to look for the world leaders, scientists, and generally the human race had to look for where does our help come from. So I mean, obviously, right now we can say like a joke, but I mean, our prayer warriors like Pastor Nganga just went underground. They didn't know what to do. So science had to come in. So that's where we had to use the ABC of science, which is maybe the agriculture, biology, and chemistry of science, to break the chain. By breaking the chain, I mean, we had to break the vicious cycle and regain firm ground. So in this talk, we're going to see how agriculture and nutrition is able to leverage its science, or I mean, the resources that were available to make us break the chain and maybe regain food security and gain good health and go back into working normally. There was an issue of which we call flexibilization. I mean, we had things like flexible working hours, but in science also people had to go full throttle. I mean, people had to really work day and night to come up with a solution. Obviously, this was a very new situation requiring us to use current tools to solve current problems in a situation that had never been seen before. Because food security, food and nutritional security is central, I must outline that, or what it means is that food and nutritional security means that all people throughout the world, including vulnerable groups, whether poor or rich, at all times have access to adequate quantities of food and safe and nutritious food to maintain a healthy and active lifestyle. And also, I must stress that food and nutritional security is a right that that is embraced by all. But the thing is, the advent of a COVID-19 pandemic threw us off balance. So threw our food and nutritional security out of balance. So we had to regroup, so to speak. So agriculture and other technologies designed ways to ensure that the world has food secure and nutritionally secure. So some of the technologies and approaches that were used by agriculture were that is what we call early warning systems. This is whereby things like very accurate weather systems that warn farmers on when it's going to rain and where and how. So that they take advantage of the little rain that is available so that they can plant their crops. That in turn making everyone food secure. Another contribution to food security and nutritional security in the agricultural sector is the adaptation of food production to climate change. Climate change right now is a major issue. So when we adapt our foods, for example, if we take non-utilized foods or non-utilized crops or underutilized crops and bring them into the mainstream, that really makes us food secure. And in addition, if we use new irrigation technologies like desalination, we've got pools of water that are very saline. So if we use things like desalination techniques or low-cost water pumping techniques, then that really contributes to food and nutritional security. Soil management is also another way of increasing food and nutritional security. If we do, like, for example, if we manage our soils, we look at the soil chemistry and look and also try to utilize organic fertilizers and not just using inorganic fertilizers the way we are doing right now. That also contributes to food and nutritional security. We can also use improved plant varieties, and also during the COVID-19 pandemic, technologies like mobile banking came in handy in ensuring food and nutritional security. Also access to information, knowing that where there's bumper harvest or less harvest, that kind of information also comes in handy. And using indigenous technologies like technologies that are indigenous or that are endemic to Kenya, then also goes a long way in ensuring food and nutritional security. Post-harvest post-harvest technologies are also important in ensuring that. And right now we have what we call WRS, that is warehouse receipt system. For example, that's what the government of Kenya did. That means we have the warehouses at the National Produce Board. All you need, if there's over harvest of, for example, maize, then you go and get a receipt. You deposit your maize, maybe 100 or 1,000 bags, and then that makes us food secure. If you need to donate maybe 5 bags of maize, you just give, you just send a message or an SMS, or you give a receipt to somebody, and then the maize will be transported to the recipient. So that is also a strategy that was used by the agricultural sector, to ensure food and nutritional security. So food, it's really important, because proper nutrition is critical for an effective immune system. And both malnutrition and overnutrition can negatively impact the immune response. For example, if somebody is obese, then that person is likely to succumb to the COVID-19 or other pandemics. So up to now, researchers agree that social isolation, hygiene, and strengthening of the body's immune system are most effective tools to combat COVID-19. So we'll just follow that vein and talk about compounds or foods that improve the immune system. In this case, propolis. This is beeswax has been determined to improve outcomes for individuals during the treatment of COVID-19. So these are we get this from our bees, from our hives, that compound of propolis. Quercetin is just a compound of flavanol that is quite ubiquitous and is found in polyphenols, fruits, vegetables, kales, onions, and things like that. It's a dietary supplement, and it's also found in beverages and a wide variety of foods. So it has been shown scientifically that quercetin regulates immunity when taken at a given dose. Also, curcumin has been reported to be able to inhibit the entry of SARS-CoV-2 into target cells and also acts as an antiviral. Melatonin, which we produce, it's a hormone produced by the human body when you sleep. I mean, it has a relaxative effect, but it has been shown scientifically to be an adjuvant. That means it simply means that it boosts your immunity when used. So it's also and also probiotics. These are microorganisms. For example, probiotics are commonly found in some yogurts like Activia. So it's also been found to scientifically proven to modulate your immune system. Vitamin D it has also been found to be very important in reducing inflammation that damages lining in the lungs and decreases the pro-inflammatory cytokine interactions, as well as increasing the anti-inflammatory cytokine concentrations. Ascorbic acid, which structure I've shown here, that's a structure of vitamin C. It's called, another name is ascorbic acid, is usually frequently been used in the treatment of colds. And during the COVID-19, it was very popular. People using oranges and things like lemon, which are full of vitamin C, that serves to boost immunity. So other nutritional supplements like zinc gluconate, organic sulfur, and medicinal herbs also reduce inflammatory responses caused by viruses, and this has been shown scientifically as well. Right. So also there's another trend that is coming in is what we call nutraceuticals and or bioceuticals. These are products that are found from, these are compounds that are derived from plants, but as you can see, the word nutraceuticals and pharmaceuticals are very related. Only that nutraceuticals are not regulated, just the way pharmaceuticals are regulated. So, for example, in this work, some researchers were able to target around 700 nutraceuticals and used a state-of-the-art drug discovery approach, and were able to target the E protein of the SARS-CoV-2. This is the structure of E protein. It's pentameric. You can see it has five sections. So it's pentameric, and out of all the work, they were able to find these nutraceuticals, octasanol, cinnametic acid usually from cinnamon, lauric acid, and ascorbyl acid. Ascorbyl is ascorbyl palmitate is a fusion, or it's an ester. There's an ester link between ascorbic acid and palmitic acid, and making it a very effective, a very good binding agent, or which is potentially from a virus by targeting the E protein. Now, sorry about the jargon, but back to that. Now, during the pandemic, we had people not really succumbing, but people mothers getting infected by COVID. But the question is, if a mom is infected, if a breastfeeding mother is infected, will she pass on the coronavirus to her child? That's a good question, because I don't think that has been addressed in the literature yet. But I dare say that mother's milk is a very strong immune booster. It's also a very strong, a very important source of food for the child. But on a light note, I mean, if young kids are having to drink milk for their sustenance and so that they have it improves their immunity, how come that adult males cannot be allowed to have mother's milk? So that's something to think about. So we've finished the aspect of the agriculture aspect. So we go to the biology aspect. Biology has been a key driver in trying to find solutions for the COVID-19 pandemic. Biology has resulted into, the principles of biology have resulted into the development of vaccines, and also the principles of biology have also resulted into rapid tests for COVID-19. So biology has come in handy. So the coronavirus biology is coronavirus enveloped positive sense single-stranded RNA viruses with a genome size of around 30 kbs in length. So in summary, SARS-CoV-2 viruses has 14 open reading frames, ORFs, that encode 27 proteins. And these 27 proteins could be structural proteins or non-structural proteins. But the four major structural proteins are the spike protein, the nucleocapsid protein, and the membrane protein, and the envelope protein. Just to go deeper, so the current SARS-CoV-2 is a relative of SARS-CoV, and if you look at it genomically, they are very related. So, as we said, it has 14 open reading frames that encode the SEM and N gene encode the genes, encode the structural proteins that I've mentioned. That's the spike protein, envelope protein, the membrane protein, and the nucleocapsid protein. And I've also mentioned the non-structural proteins that are encoded by the open reading frames that are shown. Right. So how does the SARS-CoV-2 enter into human cells? So it enters through human cells, or it infects us through what we call receptors. So the two main receptors for the human cell, for the human body, or the humanoid targets, what we call the transmembrane protease serine, which is TMPRSS2, and also the angiotensin converting enzyme 2. These are the two main receptors of the human body. Right. So when the spike protein finds a receptor on the human body, then it's able to infect us. So, the structure here, the cartoon here shows this is the spike protein. It operates like a key to the lock, or to lock out our cells front door. So if the spike protein is not able to attach to the human receptor, then you won't be infected. But because mutations, like you had of the beta coronavirus, the Delta or the variant, and the Omicron variant, this means that the spikes are able to mutate, so that they're able to through trial and error, or to come up with what we call a variant of concern. because there are many mutations, but only a few are of biological or medical significance. And the ones we've known so far are the beta corona COVID-19, the gamma variant, the delta variant, and the Omicron variant. Right. So I think we've talked about now the agriculture and nutrition. We've also talked about the biology in summary, and now we can talk about the chemistry. That's giving us what we call the ABC of COVID-19. That's the agriculture, biology, and the chemistry. So chemistry also has come in very handy. You know, at the University of Eldoret, we were able to what we call sanitizers, and also masks, and also we dealt with some form of drug discovery, just to make our contribution to the global effort to find drugs or to find solutions for this pandemic. So we carried out a lot of work because, and I must say that the drug discovery process is a very long, arduous, and expensive process, which takes around, in a normal case, it takes around 10 to 15 years. But because of the urgency and also leveraging technology, people now are able to do it in a quicker, more efficient way, and using you don't need to be a pharmaceutical company, or you don't need to have billions and billions of money, but you just use your interest and use of technology and collaborations, and then you see where you can, what contributions you can make. So in summary, we have around 27 targets for SARS-CoV-2. But using drug discovery approaches, one which is called ligand-based drug discovery, whereby that's when you don't know when you know something that is active, but you don't know the structure. But also we have what we call the structure-based drug discovery approach, when you have the crystal structure of the protein or the target, and you're able to do using artificial intelligence to zero down on to get hits before you invest more funds, resources, and time in going in the laboratory to synthesize and test these compounds. So in one of those approaches, we screened quite a few, but today we'll just talk about the helicase, which is one of the targets for the SARS-CoV-2. So the title here will be targeting the helicase, which is the non-structural protein 13 of SARS-CoV-2 using phytochemicals from Kenyan medicinal plants using a virtual screening study. So in this work, the helicase of SARS-CoV-2 was targeted to find the best binding drug-like phytochemicals from a database comprising of small molecules derived from African medicinal plants. So selection of drug-like compounds. Phytochemicals derived from the African plants were downloaded using in a certain format. And then importantly, we download like thousands of compounds in all practicality, or for all purposes of intent. And intents, we are not able to analyze all of them, but using artificial intelligence, we're able to zero down. So we look at drug-like, we call them drug-like small molecules, things that don't break what we call the Lipinski rule of 5. These are if a compound or if a small molecule is able to obey all these rules, then it's more likely, it has higher chances of succeeding as a drug. So we prepare the small molecules for virtual screening, and then we retrieve the helicase, which is the macromolecule from the from the PDB database. The next step was molecular docking using Autodoc Vida and Pyrex software, and then we obtained docking results. So docking, we're just trying to look at of the selected molecules that are drug-like, which one binds best to the macromolecule or to the helicase in this case. So that is what we were trying to look at, and we found around 10 compounds that were good. For example, this compound here it's negative 10. So if, for example, if you get a compound to be negative 12, that is very good. That means it's very negative and it has got the more the negative the binding energy, the better the binding. So in this case, this is the helicase. You can see on the screen. It has four. It's tetrameric, but the small molecule is bound here, as you can see. And then after that, we look at how the small molecule is bound. I mean, what are the protein ligand interactions? So this is the small molecule, but now we're looking at where is it binding? So in this case, you can see we have van der Waals interactions, and then we got conventional hydrogen bonding, but you can see it's attached. It's bound to glutamine and glycine to serine. So that's how it is bound, and that gives us information on how it is bound and how good a drug it is. This next molecule was negative 10.6. And you can see that is where it's fitting in that pocket. And the interactions we had were carbon-hydrogen bonds, and we had also very unfavorable donor-donor interactions. So the next one had negative 10.4, and that is where it is bound. And we also had the interactions were not so favorable, because normally we need some hydrogen bonding, and we need some hydrophobic interactions so that it can interact well with the macromolecule. But you can see here, in this case, the interactions are not as appealing as we would like them to be. Although the binding energy is good, but the interaction, the protein ligand interaction is not. Protein ligand interaction is not as favorable, right? So the next one was negative 9.9 energy. Although it is negative 9.9, but the interactions are quite favorable. You can see we got some van der Waals interaction. We got some conventional hydrogen bonding. We got also carbon-hydrogen bonding, pi-s and sigma bonding, and also pi and alkyl bonding. Here binding to 309, valine. And yeah, those are the two main ones, 309 and valine, right? The next one had negative 9.8, and it only had a van der Waals interaction and pi sigma interactions. The next one also had a 9.8 negative energy, which was quite favorable. And it also had some good interactions, protein ligand interactions, van der Waals, conventional hydrogen bonding, carbon-hydrogen, and the others as indicated. The next one was negative 9.6. You can see where it is lying there. Also, it had some van der Waals. It is linking to 309 and valine. Those are amino acids within the hydrophobic pocket of the macromolecule or the drug target. The next one, we had negative 9.5. It only had van der Waals interactions and the conventional hydrogen bonding, right? And the next one, we had negative 9.4, also had interactions with IG9 and glycine and also valine. And you can see the way it is it's deep into the pocket of the helicase. So we also had van der Waals, alkyl, and such kind of interactions. So all of them, when you put them, you can see where they were looking. And also we carried out computationally heavy molecular dynamics work to show whether if the protein, if the macromolecule is stable enough. But this indication shows that I'd like to acknowledge the principal investigator, Professor Kenga. Team wish to thank the University of Eldoret for funding this work. Thanks everyone for listening.
Thank you so much, Dr. Barasa, for the work well done. Indeed, from what you have shared with us this morning, really confirmed the statement that you said that this really carried out a lot of fun. And we also, I wanted to say that this was a
multidisciplinary study which has brought out a lot of information in the area of agriculture, biology, and chemistry.
So, Dr. Barasa, I want to allow some few reactions from the audience on your presentation, and then we'll give you a chance to respond. Anybody on the floor?
Yes. Thank you so much, Mr. Baraza. I was really curious to get to know quite a lot of things, but I just have one question. As you are doing this, with all the stigma and the fear we had of COVID-19, and we're talking food security, there are so many mothers who had COVID and they had babies on exclusive breastfeeding. What would be the impact of this COVID either affecting the child's feeding or being transmitted from the mother to the child or something like that?
Maybe you can allow another reaction and you can respond.
Okay. Thank you, Dr. Barasa, for the presentation. And I really have everything. Probably I was thinking to add another aspect, especially in the area of mental health, because people have everything very well, but they need to have now how does that affect the way the ABC work in this area of COVID-19? Thank you.
Thank you so much, Dr. Barasa. We can allow one more, that is from Professor Jono.
Thank you, Chair. Thank you, Steve. I am excited because this is the only keynote speaker from the University of Eldoret, and you picked it late, but you've done it well. Thank you very much. It's good to have people with courage like you. I have two comments to make. The first one, you made COVID-19, you have kind of demystified it when you talk about the ABC about it. And that is also exciting. But when you are discussing the agriculture bit, I would have wished to hear how agriculture contributed positively or even negatively to COVID-19 effects. Whether the virus disrupted agriculture or agriculture disrupted it, because I think there could be both, it could go both ways. And we observed a lot of things in agriculture at that time. So it would be nice to say something about that. Secondly, on the chemistry, I did chemistry more than 40 years ago, but it was nice to hear you talk about the bonds. Most of the a larger percentage of the compounds that you referred to seemed to be having the van der Waals hydrogen bonds, which to my memory, maybe these are weak bonds. And you had only one that had the carboxyl bonds, which I think are stronger. So I don't know, how does this affect the quality of the compounds in as far as combating the virus is concerned, the type of bond that they exhibit. Thank you. I'm talking from a kind of layman's angle because, as I said, I did organic chemistry a long time ago. Thank you.
Thank you so much, and colleagues and audience that have reacted to your presentation. So you can respond to Dr. Wamunga, Dr. Langas, and Professor Ochodo's reactions, and then from there we can continue.
Unfortunately, I only had Professor Ochodo, but the first and second speakers were not audible to me. But Ochodo was very clear. So I'll respond to Ochodo, and then maybe the others can repeat, or use Professor Ochodo's microphone, or maybe just write, and then I'll respond to that. So Professor Ochodo, thanks for that. I mean, when I was preparing this this talk, I mean, you came in mind, people in agriculture. You remember the sugarcane juice that you prepared, and you added some additives which were all natural. So those could serve as immune boosters and nutraceuticals. So it's just unfortunate that I was not able to put a slide of your picture there, but I had you in mind. So you are one of the people who went out of their way and realized the talents you have. So we can say that COVID-19 brought out some really remarkable attributes in Kenyans and people in the agricultural sector. For example, in the entrepreneurial skills, like in Professor Ochodo's case. And also, I think I mentioned, although it wasn't in very good English when I talked about agricultural interventions. So all these things, these are positive impacts by agriculture that were really brought out when COVID hit. For example, the people were really keen. They didn't know where they're going to get their next meal, so they had to really plan. So the early warning systems, these are technologies that people across the world, or even in maybe in the sub-Saharan Africa, have had to rely on, the early warning systems. People have had to adapt food production to climate change. For example, using some local, indigenous crops. And for example, things like when somebody's sun dries, because you don't know when the supermarkets are closed, and you have maybe a vegetable garden. So the best way to preserve your vegetable garden, like I saw people in my neighborhood do, they just sun-dry the vegetables, and those came in handy. So that's a way people adapted to innovatively. So we call that call that an indigenous technology or a post-harvest technology. And also in other case where what we call an indigenous post-harvest technology is whereby when the what do you call them, raboni, those mihogo and cassava, people just leave them out there so that it's a way of preservation. And so Professor, I can confidently say that agriculture contributed positively in the form of technology during the COVID-19 pandemic. So it really contributed contributed towards food security. And when you talk about for a drug to work, you don't require a strong bond. There's an interaction. For example, a van der Waals bond and hydrogen bond. A hydrogen bond is not necessarily weak. I think that's what people wrongly think. But it also depends on how many. It could be a van der Waals bond, which is relatively weak, but it's linked to, it is attaching to maybe 3 or 4 amino acids. That makes it very, very stable. So yes, I admire your chemistry, but in this area of drug discovery, a weak van der Waals bond doesn't necessarily mean that the drug is weak. But I must also say that that's not the end of it. This is just a preliminary. These are just preliminary work in the long process of drug discovery. It's a long pipeline. So that, for example, we've got 7,000 compounds. You can see where we've now narrowed them down to 10. So 10 are manageable, and if you apply resources to the 10 compounds, it means you stand a high chance of hitting a lead, of getting a lead compound. And also, the other thing is, once you get a lead compound, you also have to make it patentable, because you cannot patent something that is from a plant. That's a natural resource. So you need to modify it using maybe other techniques, synthetic chemistry and discovery chemistry, to be able to come up with an even more potent, more safe, and more efficacious compound. So I hope that answers you. But for Dr. Wambui and Dr. Florence, I didn't hear you. Are you able to kindly repeat your questions using a better microphone, please?
So Barasa, what Dr. Wamunga asked was on the probability of transmission of the COVID-19 to the child. And how do you comment on that? Now that we didn't have many cases of transmission to the children, even when the mothers were at the same disease, at the similar disease. And then the other issue that Wamunga raised was on the aspect of food insecurity. How was this? How prevalent was this during the pandemic? And then you can respond on that, Dr. Nganga, what to ask directly. Maybe Dr. Nganga, you can ask, and then now you can combine the two.
Okay, thank you, Dr. Balata, for your presentation. And also thank you for enlightening us about the ABC and the effect of COVID-19. My issue was that I would like to just, you mentioned the role of mental health when it comes to COVID-19 and how it relates to the ABC. Looking at many of us went, there was bereavement, there was fear, there was a lot of jobs and many other factors. So how does the role of mental health twine with the ABC that you have just shared with us? Thank you.
Okay, yeah. Okay, I'll start with Dr. Wamunga's question. Oh, yeah, it is it's been it's a puzzle, because we expected, or rather, if you listen to the Western media, they expected that Africans will die in their troves, will be found in the streets dead, because our health systems are not well developed. But we also expected us to die, but we didn't. So that is speaking about the adults during this COVID. It means that Africans or people in the tropics are doing something right. Maybe because of, for some reason, we don't know why, but we didn't succumb. So that is one observation which we'll really need to look into. And also, as you say, for mothers, even mothers who had COVID, infected with COVID, did not pass on. Or if they did, then the children did not manifest the effects of COVID. Having said that, it is possible that most of us were infected with the COVID-19, but only that it did not manifest into the severe COVID, because our immunity was able to ward off. So I think I'm not an expert in this, but I think mother's milk has got those nutritional and protective aspects that protect young children and boost their immunity. I'm not an expert in this, but that's just my layman's comment. And for Dr. Nganga, yes, I'm sorry for just saying ABC of COVID-19, but that's not to oversimplify the situation, because it was grave. It was really, it affected many people. Because, for example, if after the lockdown, so many people were laid off. They lost their jobs, and once you lose your job, that means you don't have the money to buy food, and you constantly worry, how are you going to take your children to school? How are you going to pay your fees? And for example, many of us are parents, and we actually we felt that we were paying school fees every week or every month, because it was just high schools and primary schools were just opening, and it's just open and shut, and the moments and during opening days, you expected to pay. So the issues of mental health resulting from loss of livelihoods, or resulting from even loss of loved ones who had succumbed, or were on the rise. But I think you pointed out rightly that the issue of mental health will really come on the forefront, because most of us, when we say we're going to the hospital, it just means we are ill, our bodies are ill, or maybe we have malaria or things like that, tuberculosis or something like that. But rarely do we go to see a doctor for mental health issues, because we feel that we are not we feel that mental health is I think we are not schooled, or we are not brought up to think and consider mental health to be important. But I think things should change, and we should learn that mental health is just as important as physical and bodily health. I hope that answers you, Drs. Yan and Dr. Florence.
Okay, thank you so much, Barasa. Just before we allow more reactions, there is somebody on YouTube by the name Valentine Jeruta, who is asking that what are some of the herbal and food combinations that can be used at home to boost the immunity?
Yeah, okay. Mostly, for example, me, I just go for spices. If you as food as additives, if you go to the Muindi shops in town, you get some really good spices which you can add. But at home, if you don't have access to spices, I'll just normally go for a variety of traditional foods, like vegetables like terere and amaranth, cowpeas. Just eat well, green leafy vegetables, and also fruits, and plenty of hydration. I'm not talking from a specialist point of view, but I'm just talking from a point of view of information and what I do at home. I hope that helps.
Okay, thank you so much. Let me allow another set of so let me, I'll give some from, but let me allow first on the floor.
Thank you, Dr. Baraza, for the good presentation, telling us maybe the chemistry of these plants and how they help in preventing COVID. Before I ask my question, my name is Dr. Emmanuel Ayuant. We have had interest in these phenolic compounds, especially in even inhibiting some bacterial growth. So I have two questions. One is the dosage. Which dosage are we talking about when we are saying that this can inhibit the virus? And does it mean that each chemical, each phytochemical has the same effect on the various variants? Then one thing that I couldn't capture from your presentation is the actual mechanism, because like in bacteria, we usually say that this phenolic compound can maybe damage the cell membrane and cause leakage, or it can inhibit synthesis of maybe enzymes that help in maybe metabolizing a product, or maybe they can maybe scavenge some of the carbon sources like iron. So what is the actual mechanism? Because van der Waal interaction may not necessarily mean that these phenolic compounds can indeed inhibit or slow down or maybe prevent the severity of COVID symptoms. So what is the actual mechanism that you are hypothesizing that would actually work out at the end of your study?
Yeah, thanks for that's a very good question. Thank you. So you talked of phenolic compounds and about dosage. I mean, what we're doing actually just a batch screening, but we need to go to the lab. If you need to find the dosage, you need to carry out those experiments to find the ED50, EC50, or EC90, things like that. But these are just preliminary findings for you to, these are just elimination method. And then for the mode of actions, I think we said in one of the slides that we get different kinds of proteins. The coronavirus has got different kinds of proteins. So we talked about the structural proteins. These help the structural proteins. We talked about the S protein, the spike protein. We talked about the membrane protein. We talked about the nucleocapsid protein and also the envelope protein. Okay, those are around the 4 major ones. But we got many others, which we talked about the non-structural proteins. These they don't form part of the structure, but they play a role in virulence, yeah, and pathogenicity of this compound. These are non-structural proteins. For example, the helicase is a non-structural protein, so it affects. So if you target that, it will affect the pathogenicity. Or for example, an ecosummary. Anyway, so the mode of action is that it affects the severity of transmission from person to person. That's how the helicase or NSP13 works. But if you maybe target other compound, we've done different works that has targeted the spike protein and also has targeted the membrane protein, envelope protein. So those are with different modes of action. So it depends on your target. But important for the ones, I mean, COVID-19 keeps mutating from one phase to another. So the best thing is what we call, you can use an approach we call polypharmacology. So whereby you're targeting different drug targets. That one makes it more effective, and it also makes the COVID-19 less susceptible to what we call mutation, where there's what do we call it, drug resistance. So there will be less drug resistance if you use the polypharmacology approach. I hope that helps.
Okay. There's a comment on the chat, Dr. Barasa.
Okay. All right, let me check.
About the new technology.
Okay.
You can comment on that.
There are useful ways of preservation using agriculture and biosystem technology, also using solar. Yeah. Oh, yeah. Thanks. That's a smart one. Yeah. Yeah, I didn't catch everything. So that's I agree. You can preserve using. Here, there are useful ways of preservation using agriculture and biosystem technology, also using solar technology. Yeah, but I talked about people drying some vegetables when the season is when things are in abundance, and then serving them for future use. And then another one is questions to you. Okay. Is there any other question? Who can? Can't see any other question. Yeah.
Let me allow some other people to ask something. Professor Abu, you had something? Professor Uchiwada?
Yeah, I don't know whether I'm on.
Yeah, you're on.
Okay. Steve, I think this other question I have, maybe you answered it halfway. You say that you did virtual screening.
Yeah.
I'm trying to understand that. That meant that you got secondary data from various sources and identified some compounds, and you said there were thousands. And then, I don't know, you blast them into an established library, and you get more information about these compounds. And that assisted you to select the 10. And then I'm saying you answered part of this in that you just did that screening. You have not gone to the lab so that now you can do other tests with the same. Because I wanted to ask whether you have been able to link these compounds to some of the traditional medicines that we know are curing or trying to assist us with COVID-19. Have you been able to kind of link them or not yet? And the second question that I have, the fact that these 10 compounds, they seem to be attaching themselves at almost the same points on the virus. Does that mean they have the same mode of action, or does it mean that they are similar or the same? Thank you.
Thanks, Professor Chwada. Now, I think what the point I need to drive home is that drug discovery is very expensive. You need a few billion to do that. But we can either sit back and say that that is work for the Mzungu or the big pharmaceutical companies, or we can use our knowledge, training, and our ingenuity to contribute to this cause. So we chose the latter. We chose to do something about this. And we can also say that we don't have funding, or we can say, oh, we don't have labs. We can write 101 excuses, but we choose not to do that. What we do is just like you can think of M-Pesa. If you go to London, there's no M-Pesa. But in Kenya, because of our ingenuity and creativity, we have M-Pesa, and people, it's doing wonders. The Mzungu's wonder. So we can do the same for drug discovery using our training, our knowledge, and our innovativeness. So in this case, we can either choose to take one tree or one mitishamba, and say that we're going to try and see if it cures, and just do the normal, traditional way people have done for many years. Or we choose the approach. So this current approach is very cost effective, and it's very trendy, it's very current. It uses state-of-the-art technology, the technology that is used in the pharmaceutical industry. So we use that technology. So we can, for example, we've been able to look at, to assess around 1,600 plants, okay? So if you assess the metabolites from 1,600 plants, you see that you are already looking into millions of shillings. But we're able to cost effectively do that. Now, for 1,600 plants, you get around maybe 15,000 metabolites, right? So you can either choose to look for money to assess each of these 15,000 metabolites or use technology to zero them down. So what we do is look for outliers or what we call drug-like properties. So compounds of the 15,000, compounds that don't obey are not drug-like, we kick them out. So we remain with something like maybe 1,000 compounds. So we've really saved a lot of money and time for that. So for the 1,000 compounds, we further screen them to get in this what we call 10 compounds, the 10 compounds. But we don't leave them there. We go into what we call molecular dynamic simulation using more powerful computers. Right now, we've got access to the South African computer, CHPC. I think it's in University of Johannesburg. We recently got access. So of this, we need to look at the compound. If, for example, let me just go to this. They are not at the same spot. Just a moment. Just a moment. Summary. Yeah, this one. So you can see these are the compounds. You can see they are binding at different places. They are not binding at the same place. You see they are binding at different places. And if you turn that way, each one is binding at a totally different position. But for these ones, now we need to interrogate them further and see that if we check them or under different conditions, or maybe we increase the temperature, we increase the pressure using our supercomputers. If we increase the temperature, pressure, and also the volume, will it be what attributes do we see from them? So from there, we'll be able maybe to come only with two, and with those two, now we call that is either a proof of concept or a preliminary data. Now, if you go to maybe a funder or a funding agency and tell them, we've done all this work, but we're really using state-of-the-art science and current science, we know that these two compounds are likely, very high, there's a high likelihood to form a drug, then there's a high likelihood that will be funded. But having said that, it doesn't mean that I'll just use that compound. I'll want to synthesize that compound and also make what we call to do structure activity relationships and see if this compound is better or not. Yeah, I think Kiplagat is getting impatient. So I hope I've answered Professor Choda. If not, you can catch me over a cup of coffee and then we talk about it.
Yes, Steve, I would love that cup of coffee for a further discussion. Thank you.
Yeah, thank you. Yeah.
Okay, thank you so much, Dr. Barasa. I have some comments online, and Gertrude is saying that besides the use of spices, one can also use fruits which are rich in vitamin C, A, and E. Yeah. And that is just a comment, but somebody is asking that from the ABC that you have shared, can also one use the ABC of anthropology, belief,
yeah,
culture to help in food and nutrition security?
Yeah.
And then somebody also has commented, that's Valentine, that in uninfused garlic root, ginger root, and turmeric root to fight the flu and colds. That is somebody who has used this one in the past.
Yeah.
And he's saying that this one also helped her family members with COVID-19.
Yeah.
Jacob is asking that can you comment on the effects of and efficiency on the ongoing vaccination for COVID-19 and the misconception about its alleged negative side effects? Dr. Barasa?
Yeah, I'm not a specialist in vaccines. I've omitted them, but what I know is that we've got two types of vaccines. We've got the mRNA vaccines and the vector-based vaccines. Vector-based vaccines. So, for example, what we have, what do you call it? The one we got from London. What is it called? The one we were given. The Pfizer is a vector-based, I think. The one from which is this pharmaceutical company that brought us yeah, the other one is
Pfizer,
mRNA.
Pfizer,
There's Pfizer
AstraZeneca.
and AstraZeneca. Yeah, so AstraZeneca is a mRNA based vaccine and Pfizer is a vector based vaccine. There are others forms of vaccines that are still in, being deployed. I don't know what Moderna is. Actually, I work with small molecules, and these vaccines are actually macromolecules. So, in terms of safety, I don't think there's need to fear, because we've already taken these jobs, and most of us travel in matatus and go in crowded buses and shopping malls and all that, but we feel protected because of these vaccines. So I'll urge people to adopt vaccines, and also the booster vaccines, because they are there for us to use. We shouldn't fear, because most Kenyans are vaccinated either for BCG or any other form of vaccine. So this shouldn't be a problem. So I would urge people to take their full doses of vaccines. Thank you.
Okay, thank you so much, Dr. Barasa. I want to ask Professor Sudoi to say something.
Yes, thank you very much, Dr. Barasa. I want to appreciate your quick response, especially when we requested you to come in handy when our keynote speaker was not able to join us. Indeed, we have appreciated your presentation. It has been quite educating. In fact, I have never understood what you do, despite the fact that we are the University of Eldoret is funding some of this research. And I was wondering what this drug targeting. But today, I'm more educated. Thank you very much, and I want to appreciate it. Thank you.
Yeah, thanks.
Okay, thank you so much, Dr. Barasa, for the informative session that we had together with you this morning. And I think as a university, from what has been mentioned earlier, is that we are very proud to have such a team that has brought us this very wonderful information. I think this has helped not only us as a country, but also beyond the borders of this nation, because of the information that we have been able to get this day. So that is on behalf of the organizing committee and your university, I want to say thank you very much, and wish you well in your endeavors as you continue to inform the world on the aspects of the ABC. Any closing remarks from your hand? Maybe we can give you a minute.
I'm just very grateful just to tell Professor Sudoi that whenever you call on me, I have to rise to the occasion. And thank you for giving me the opportunity to serve. I'm here to serve. Thank you.
Thank you.
Bye.
Did you upload it?
The University of Eldoret is a modern university situated approximately 9 kilometers northeast of Eldoret town in Uasin Gishu County, Kenya.
Thank you so much
Founded in
for
1946 and converted to
being
a
active
teachers training
during this
college
session.
in 1984. In 1990, it became Chepkoilel campus of Moi University,
Reliably
offering
informed that,
natural,
this
basic
around.
and applied science programs.
So
In
can,
August
at this point, I think
2010,
we will
the
break for our
campus
tea.
was upgraded to Chepkoilel University College, a constituent college of Moi University. Upon the award of charter by the President on 11th February 2013, the University College was renamed University of Eldoret. Our vision is a premier university that nurtures global leaders and innovators. Our mission is to provide quality education, training, research and consultancy in science, agriculture and technology to meet the needs and aspirations of a dynamic society. The University of Eldoret is ISO 9001:2015 Quality Management System certified. The university is led by the Chancellor Ambassador Professor Judith Mbula Bahemuka, who is the titular head of the university, the council comprising of the chairperson and members, and the University Management Board led by the Vice Chancellor Professor Teresa Akenga. The other members comprise of Deputy Vice Chancellor Academic and Student Affairs Professor Ruth Otunga, Deputy Vice Chancellor Administration and Finance Professor Wilson Ngetich, Deputy Vice Chancellor Planning, Research and Extension Professor Philip Raburu, the Registrar Academics Professor Paul Taruz, Acting Registrar Administration CPA Francis Ikapel, Registrar Planning Dr. Benjamin Mwasi, Acting Finance Officer CPA Ereu Totona, and Senior Legal Officer Mr. Stephen Anditi. University of Eldoret is science, agriculture and technology based and has grown steadily from the initial schools of forestry and science to the current 9 schools with 34 academic departments. The schools are led by a team of deans who also provide academic leadership and management of the faculty. They include Dr. Oliver Kiplagat, Acting Dean, School of Agriculture and Biotechnology, Professor Robert Otuya, Dean, School of Business and Management Sciences, Dr. Paul Odwori, Dean, School of Economics, Professor Kisilu Kitainge, Dean, School of Education, Dr. Julius Kolongei, Dean, School of Engineering, Professor Gelas Simiyu, Dean, School of Environmental Studies, Dr. Jacob Onyango, Acting Dean, School of Human Resource Development, Professor Boaz Kaunda Arara, Dean, School of Natural Resource Management, Professor Samuel Luta, Dean, School of Science, and the Dean of Students, Dr. Lelei Kiboi.
This is one of the big schools in the University of Eldoret with several programs covering all the fields in agriculture, both at undergraduate level and postgraduate level. Also, we have some diploma programs. We strive to be a center of excellence in agriculture, as our vision is to be a center of excellence locally and globally in agricultural sciences, technology development, and transfer. We have a total of 6 departments within the school, which are under the dean. So we have a wide range of courses, and our students are not limited to work in agriculture, although most of them work in agriculture, but we have other options which are not traditionally agricultural enterprises, but nowadays employ our students.
The School of Education is the largest school at the University of Eldoret. We serve about 50% of the total student population. The school is housed at the main campus in the education complex and also at the town campus located at Musco Towers opposite Sirikwa Hotel, Eldoret town. The School of Education is organized in 8 departments. We at the School of Education prepare teachers and trainers to be employed by the Teachers Service Commission and the Public Service for Technical and Vocational Education teachers. Our graduates go into industry and private practice. The School of Education programs are highly popular due to the many avenues for employment after undertaking the courses. Graduates can go into teaching, they can go into industry for technology education, and also some establish their own businesses.
The School of Engineering. The School of Engineering was founded in 2011 with 3 departments which are fully accredited by Engineers Board of Kenya. The first department is Agricultural and Biosystems Engineering. The second department is Civil and Structural Engineering. And the third department is Mechanical and Production Engineering. All the above 3 programs ran for 5 years. The School of Engineering has actually a number of unique strengths. The first one is that we have qualified and dedicated staff with varied experiences in different fields of engineering. Secondly, our programs are marketable, both at graduate and undergraduate level. We also have excellent teamwork among academic and technical support staff and also with students. We also have good cooperation and networks with neighboring institutions, industries, and other stakeholders. Without also forgetting, we are also located in a serene environment next to a fast-growing city. The School of Engineering has 4 administrative units. Mainly, apart from the 3 departments I have mentioned, we also have the school, the Dean's Office.
am Professor Samuel Luther, Dean, School of Science, and an Associate Professor of Chemistry. We have a mission and vision. Our vision is to be a vibrant center in excellence in generation of scientific knowledge. And our mission is to create, innovate, disseminate scientific information through quality teaching and research. As a school, we have 4 departments, namely Department of Chemistry and Biochemistry, Department of Physics, Department of Mathematics and Computer Science, and Department of Biological Sciences. We offer programs both in pure and applied sciences, and our programs are market-driven and sensitive to global trends in terms of innovation.
The university has directors who coordinate the formulation, review and implementation of university policies. They include Dr. Victor Kimeli, Directorate of Information and Communication Technology, Professor Donald Otieno, Director Quality Assurance, Dr. David Waswa, Director Strategic Planning and Performance Contracting, Professor Beatrice Were, Directorate of Board of Postgraduate Studies, Professor Vincent Sudoi, Director Research and Innovation, Professor Grace Cheserek, Directorate of Industrial Linkages, Partnerships and Collaborations, Professor James Olekiapi, Director Resource, Mobilization and Strategic Initiatives, Dr. Geraldine K. Motola, Director Gender Equity and Diversity, Dr. Nicholas Rope, Acting Director, University of Eldoret, Eldoret Town Campus, Dr. Nicholas Macau, Acting Director, Open, Distance and E-Learning, and Engineer Emmanuel Kinyor Mutai, Acting Director, Income Generation Units. The university operates 2 nursery schools, 2 primary schools, and a secondary school. The University of Eldoret has a town campus for evening and weekend classes that is located at Musco Towers opposite Sirikwa Hotel, Eldoret Town.
Welcome to University of Eldoret Town Campus. We are situated in Central Business District in Eldoret in a serene environment, conducive for learning, and we have several courses, programs in the campus from different schools, majorly School of Education, School of Business Management, School of Agriculture, School of Environmental Studies, and also short courses. These are vocational courses based on needs assessment. These are people who are working and there are some skills that they require. So we develop such courses and we offer here in town campus. So the mode of delivery here is that we offer these courses evenings and also weekends and also full-time. There are those students who are not engaged because mainly these are students who are self-sponsored, and those who are not also maybe engaged elsewhere, they are not working, so they can also come in as full-time students. So we admit our students in January, May, and also September. So the course is actually tailored so that a student can finish within a shorter period, unlike in main campus.
We also have Nairobi Liaison Office at Pension Tower, 12th floor, Loiter Street, for efficient resource mobilization, corporate marketing, stakeholders meetings, and university meetings.
Welcome to the University of Eldoret,
the flame of knowledge and innovation.
We are the best university in this country.
Jerusalema ikayalami ilondoloze uhambe nami zungangishilana. Jerusalema ikayalami ilondoloze uhambe nami zungangishilana. Dawo yami ayikholana, buso wami awukholana. Ilondoloze zuhambe nami. Dawo yami ayikholana, buso wami awukholana. Ilondoloze dawo yami ayikholana, buso wami awukholana. Ilondoloze zuhambe nami. Dawo yami ayikholana, buso wami awukholana. Ilondoloze zuhambe nami. Jerusalema ikayalami sumangishilana Jerusalema ikayalami ilonoloze uhambe nami sumangishilana dawo yami ayikholana buso wami awukholana ilonoloze suhambe nami ilondoloze
you can unmute and respond. Hello, are you people hearing me?
Yes, we can hear you, Dr. Njoroge.
Oh, thank you. Dr. Omega, you are one of the presenters. Thank you. Elijah is in. Elijah Kamau. Benedict Kipkemoy. Lynette Oyimbo. So those are the presentations we're going to, okay, thank you. Those are the presentations we're going to have in this session. And if Elijah cannot hear me, or he can already start presenting, we are going to upload his presentation. Elijah, can you hear me? Heka, please unmute. If he's not ready, we can start off with Dr. Omega, Joseph Omega, and his presentation is on prevalence of bovine and ovine paratuberculosis in Kericho County and Konoin sub-county, Kenya. So welcome, Dr. Omega, and go on. The floor is yours.
Thank you very much, Madam Moderator. My name is Omega, as you have been told, and I would like to present. Next page, please. Yeah, that is the topic of the work I'm presenting: prevalence of bovine and ovine paratuberculosis in Kericho County. What is happening?
Oh my God. I'm in the wrong one. I should be in US.
Go on, Doc.
Okay. Some of this terminology, since this is a cross-cutting session, maybe I need to simplify a few things. Bovine means the cow family or the cattle. Ovine is sheep. Paratuberculosis is the disease I'm dealing with. And then there is Kericho County and Konoin sub-county, which is in Bomet County. Next. The disease, which is called paratuberculosis, is caused by a bacteria, which is called Mycobacterium avium subspecies paratuberculosis. It is a very fastidious bacteria, very difficult to grow in culture, in vitro, and but it has a lipid. It has a lipid-rich cell wall, which enables it to persist in the environment. It can persist after being defecated through feces. It can last in the ground for up to 9 months. And in vitro, it can only grow in the presence of a chemical called Mycobactin J. And it's also a notifiable disease. A notifiable disease is a disease which, due to its economic importance, has to be reported to the veterinary office immediately it is suspected. The animals that are affected by this disease include ruminants, both wild and domestic. Pseudoruminants like camels and llamas, non-ruminants like horses, pigs, even poultry, and primates, including man. In man, there is a disease called Crohn's disease, which is suspected to be caused by this bacteria. And this bacteria is associated a lot with acidic soils. Acidic soils are these soils where tea, especially the tea growing areas. Now, how is the disease transmitted? The disease is transmitted through if you drink milk from an infected cow, you will get the disease. Or if other animals drink milk from infected cow, they get the disease. but calves also get the disease by suckling udders that are contaminated. If the udder is contaminated with the fecal material that has the bacteria, that is how the calves get the disease. It is also transmitted through ingestion of contaminated pastures, feed, or water. As you can see, this pasture with all this fecal material, if some of it has the bacteria and the animal is feeding around it, definitely it will get the disease. Clinical signs. The first clinical sign is profuse watery projectile diarrhea. The animal shoots diarrhea. You can see from this picture on the right, you can see how long that fecal material, the animal was standing where there is the big part, and it shot hukumbali. If you measure that thing, it's almost a meter away. That's why it's called projectile. Another clinical sign is gradual irreversible emaciation. The animal just goes thin and thin and thin. And you can also see the black cow. There is a swelling under the jaw. It is called bottleneck. That's edema, which means the animal is suffering from hypoproteinemia, which is basically a sign of emaciation. Next. There is also voracious appetite. The animals feed and feed and feed, yet their body condition keeps on getting worse and worse and worse. Next. If you carry out postmortem on the animal, you will find the predilection site for the bacteria is in the intestines, especially the small intestines and the proximal large intestines. And you can see these dark spots on the picture on the left. These ones are lymph nodes. What are called the mesenteric lymph nodes these ones are terribly enlarged. They are not supposed to be this big. And then you can see on the right, on the right, you can see the folds in the intestines. This multifolding is a sign of inflammation of the intestines, and it hinders the intestine from carrying out its function of absorption of water and absorption of nutrients. And that's why the animal has diarrhea and keeps on growing thinner and thinner. Next. In diagnosis, there are many diagnostic ways, many ways of diagnosing the disease. One of them will be by the clinical signs, like especially for the field officers or the farmer. You will look at the clinical signs, the ones I've already explained, or the postmortem signs. But in the lab, you can do serological tests like ELISA, which is enzyme-linked immunosorbent assay, AGID, which is agar-gel immunodiffusion, and CFT, which is complement fixation test. You can also do microscopy. You can stain the fecal material, or if you take a biopsy of the intestine, the affected portion of the intestine, and you stain it with a stain called ZL-Nelson stain, you are able to see the acid-fast bodies. You can also culture the bacteria, and you can also carry out a polymerase chain reaction, PCR. Now, statement of the problem. There is no epidemiological studies carried out in Kenya about this disease at all. The distribution of the disease in the country is totally unknown. The strains, like you saw sheep and cattle get the disease, but it has been shown that the strain that affects the sheep is different. It may be different from the one that affects the cattle, but that one has not been ascertained. The mode of spread, how does it move from one place to another? Socioeconomic impact, because this is an animal, it's a disease that is destroying our animals slowly, and people are suffering from treatment, yet it has no treatment, and people are spending a lot on drugs, and so on and so forth. There is a possibility that it's a zoonotic disease. If it is the one that is causing Crohn's disease, then it is zoonotic. This one also needs to be ascertained. And there are no policies or strategies laid nationally or regionally to manage the disease, yet it is a notifiable disease. But it's because there is no data about it. Also, until I carried out this work, there was no published scientific research on the disease in Kenya. The diagnosis in the laboratories is not reliable because they use the ZN test, which is has a very poor specificity and sensitivity. And when OIE is the World Animal Health Organization, the equivalent of World Health Organization for humans, and it is the one that standardizes diseases of animals. So for it to accept that a country has the disease, there are specific tests that it recommends to be used to ascertain that disease is there. Now in Kenya, for paratuberculosis, the tests that are recommended are culture and PCR. And those tests have never been done in Kenya until I carried out the work. The disease is slowly but steadily increasing in incidence and spreading in Kenya, and unnoticeably, very quietly. Yeah, into the work. The area of study I chose, the former Kericho district, which is now Kericho County and Konoin sub-county of Bomet district. And I chose that portion because it has showed a steady increase of reports of the disease after the 1997 El Nino rains. At that time, it had shot from 1 case per year to 14. And by 5 years later, the cases had reached 300 per year. So that is a very important thing. So we selected 423 households, which are represented by these dots in the map. These dots were obtained by GPS. Each one of them represents a household that was visited. And from each household, we collected fecal and serum material from 1 cow and 1 sheep that was randomly selected. Next. This is how we were getting fecal sample from the cows. Next. Next, please. This is how we were getting blood from the goats, from the sheep. Please, from the sheep. Take me back there, please. Yeah, this is how we are collecting blood from the sheep and from the cattle. Next. And for the fecal material that we took, we carried out 3 tests. One was the ZN stain, and then we cultured in Herold's egg yolk medium. And for each sample from the sheep and the cattle, each sample we did one with and one without Mycobacterium J. And then there are some selected samples we took, as I will explain later, and we carried out real-time PCR on them. And for the serum we collected, we did an antibody ELISA. Results. When we did the ZN, there were 2 types of results that we would obtain. This one is the recommended. If you see a cluster of the acid-fast bacilli, like this one on the left, then that one you are almost sure you have seen Mycobacterium paratuberculosis. But on the right, you can see this arrow is pointing to just one single acid-fast body. It's not a cluster. That one is what we call inconclusive. It may or may not be positive. It's inconclusive. Next. So based on the ZN diagnosis, we carried out the prevalence. We calculated the prevalence, and the prevalence, of course, there were 423 head of cattle, 352 were negative, 17 were positive, the clustered, 54 were the inconclusive. Now, when you calculate prevalence, which is the number of sick animals over the number of tested animals, for the inconclusive, it is 12%, 12.8%. For the positive, it is 4%. Now, because this prevalence, this inconclusive, you don't know whether it is right or whether it is true or false, you now give a range. When you are giving your prevalence, you give it as a range, starting from what you are sure about to what is the total between what you are sure about and what you are not sure. So we say by ZN, the prevalence of paratuberculosis in Kericho County is between 4 and 16.8%. And for the same case, for sheep, it is between 0.2 and 2.2%. Next. Culture. We cultured the bacteria in Herold's egg yolk medium, and out of the 423 samples, there were only 2 samples of sheep, of cattle that were positive, and only 1 in sheep that was positive. Now, these you are seeing arrows on the left. You may not see anything, but those are small colonies. Those arrows are pointing to small colonies in those media, and this is the most precious part of this research. Next. So going by what we found by culture, the prevalence is 0.47 for cattle and 0.25 for sheep. Now, the colonies, as I told you, the bacteria is very fastidious in the way it grows in vitro. The first colony we saw at 14 weeks from the time we inoculated. The second colony we saw at 40 weeks for the one of sheep. 40 weeks means how many months? 10 months. After 10 months of incubation is when we saw a colony. And then for the sheep, we saw it at 23 weeks. Next. Then we carried out antibody ELISA. Next. For the antibody ELISA, it also has its inconclusives, and therefore the prevalence is between 1.9 and 2.1, and for sheep, it is 0 to 0.3. Next. Then I carried out real-time PCR. Now, this real-time PCR is different from the conventional, because this one, you are able to see how the DNA is being multiplied right on the screen of a computer, of a laptop on top of the machine, and this is the result. Now, this horizontal line is the cutoff point. So any line that has gone above the cutoff point is positive for the disease. Next. Now, for PCR, I could not do all the samples, all the 423 samples of sheep and cattle, because it was too expensive. So what I opted was to use the 30 samples that I had to test if the tests I had done in culture, ELISA, and ZN, how accurate was I in the results I got? Because PCR, it's definite. It's almost 99% sure. So I was using it as my detector of how good the other tests I had carried out were. So I specifically, intentionally chose samples whose results I already knew by the other tests, and then subjected them to PCR so that I see whether what I got in those tests was what PCR was also telling me. For instance, this fecal sample that were positive by ZN, I took 2 samples, and they were also positive. PCR also confirmed they were positive. The ones that were inconclusive, by ZN, I took 13 samples, PCR confirmed 12 were positive. So when you take all these samples, after taking all these results, I carried out what is called Pearson correlation coefficient test, which gave me 97%. And what that means is PCR told me that the results I had got by the 3 other tests I had carried out were in the range of 97% accurate. Conclusions. Jones disease has now been confirmed officially in cattle and sheep of Kenya. Number 2, prevalence of paratuberculosis in the former Kericho district ranges from 4 to 16.8% in cattle and 0.2 to 2.2% in sheep. Milestones. This is the first time culture of Mycobacterium paratuberculosis has been successfully carried out in a Kenyan lab. This is the first time PCR has been successfully carried out in a Kenyan lab for the same pathogen. This is the first time prevalence studies have been carried out on the paratuberculosis in Kenya. And this is the first time the pathogen has officially been confirmed in Kenya. My recommendations: the disease should be elevated from neglected to emerging so that more funds and attention can be paid to it. Massive awareness campaigns about the disease need to be given out to both farmers and even professionals. And I have another paper I've written about, I will be presenting in the afternoon, on knowledge, attitude, and practices. And that's when you realize that this disease is totally unknown, even by the farmers whose animals are suffering from it. And then strategies for diagnosis, prevention, and control should be laid down, and further studies need to be carried out in various areas. Because the information I've given is very basic, baseline information. Next. Thank you very much. That's the end of my presentation.
Yeah, thank you, Dr. Omega, for that educative, interesting, but yet caring kind of presentation, because it's about a disease that looks like it's one of the emerging diseases, but we are not aware of it. And you've said clearly that it's kind of zoonotic disease, so it can affect man. So it's a bit scary. And thank you, because you've said that you're going to continue with further investigation and further research to bring this disease to be known by people and even to the health community, so that we can tackle it before it becomes a pandemic. Thank you so much. So I'll open the floor to the participants to either comment or ask questions to Dr. Omega in accordance with the presentation he has done on Jones disease. So you're welcome. You can raise your hand. You can write your comment on the chat box so that we see it. So you can raise your hand, we see you if you want to talk, or you put it on the chat box. Thank you. If no one has got a question or a comment, I have a few questions I want to ask Dr. Omega regarding this disease. I'm sorry, I pronounced it wrongly in the first time. It's paratuberculosis. Yeah, so I'm sorry for that. And now I know in common knowledge, it is called Jones disease. Now, you said it's very prevalent in acidic soils, and you dealt only with Kericho and Bomet. But even where we stand on the ground of Uasin Gishu, we have ferrosols, which are very acidic in nature. Do you think that the disease could be here or any other places like Western Kenya where we have acidic soils? Hello, Dr. Omega.
Can I respond?
Yeah, you can.
Oh, thank you very much. It is true. Even here in Eldoret, you know, I also worked in the veterinary laboratory of Eldoret. That disease is also in Eldoret. It is also in Kitale, and we have confirmed by diagnosis from those two places, this disease is around.
Okay. When did
and
you
there is even somebody who did his master's around Kitale, and he got positive results. So it's a disease that is with us. But as you can see, I can ask the whole audience if anybody knows of a disease that's called Jones disease. Very few will say they know, because Julikani.
Yeah, we've never heard about it. And when was your study done?
This study was done between 2012 and 2015, the research itself.
Wow. So you can imagine if you already said within 1 year, the cases had risen to 300, a figure that you gave. So now between 2012 and 2021, what do you think?
Things are getting worse, and that's why I'm really talking about it.
The other question is that you say this disease can also be transmitted to human beings, and you only took samples from animals. did you take or a step or to consult with the health community or the health experts, I mean human health experts, to see whether we have this kind of tuberculosis in man or in human?
Yes, in the next paper that I'll present, it's about knowledge attitude, and that's the time I took questionnaires to various hospitals, we talked to various doctors in the area of study, and I don't want to preempt the results of that time because nobody will now attend, but all I can tell you is that disease might be there, but it is equally unknown in humans, just as it's unknown in animals, and it is there.
Wow. So that's why I said at the end of your presentation is a bit scary because we might be treating other type of tuberculosis, but yet this one that is transmitted by animals that we are using their milk, we are using the farm, as I'm a soil scientist, so we use a farmyard manure to apply to the field. So I think we might be having a lot of contamination which we are not aware of, and it's an interesting study which can use combined disciplinaries, and then we see what whether we can be able to arrest it. So thank you so much, Dr. Omega. I rest my case unless there's anybody else who have got a question. If not, we'll go to the next presentation. Dr. Kamau, are you in?
Yes, I am, Daktari.
Thank you so much. You're welcome, and congratulations that you received your doctorate recently. You're welcome to present.
Okay. Okay, thank you very much. I hope all of you can clearly see my screen.
Yes, we can.
Thank you. I'm Dr. Heka Kamau from the University of Eldoret, and I'm going to present part of work that was carried out on African nightshade edible berries. Doing the presentation on behalf of my colleagues, Professor Glaston Kenji from JKUAT, Professor Julius Minor from JKUAT, and Dr. Emmanuel Ayua from the University of Eldoret. The bit of work I'm going to present on is on the sugar content and physical characterization of berries from 4 selected African nightshade edible berries. To my introduction, sorry, just a minute. Okay, so we know that the African nightshade has been popularized as one of the vegetables that improve the micronutrient content in the diet. And a lot of studies have been done on this crop that is from the leafy perspective, but not considering the other parts of the fruits which could also be edible, such as the stems and the berries. And you find that there has been documented evidence about the antioxidant value, the nutrition benefits, and proven nutraceutical potential of these vegetables. And literature proves that in the past, or even recently, or currently, it is being used to handle different conditions in the body, like stomach aches. You'll find even the berries, they are squeezed and the juice is put on the gums of children who are having teething problems. And it's known to soothe that pain. It has also been used in dealing with some fungal infections and such like things, showing that it has some pharmaceutical properties. However, you find that since the crop has only been regarded as a leafy vegetable, and a lot of study has been done on the leafy part, then the berries have been neglected. Therefore, but you find that there are some people who do not prefer consuming the leaves because of certain properties like the bitterness. And therefore, we feel that it is not fair that everybody does not get the benefit of this crop. Therefore, can we find alternatives of
recording in progress
maximum use of this crop? And this is why we came up with the concept of the berries. And just a diagrammatic representation there of the berries, as you can see, there's the one with the reddish or is it orange fruits and the black one. So majorly you'll find the berries having those two colors after ripening. So I find some studies or some research has indicated that the berries are poisonous, but this is the myth that tend to be demystified, because not all berries are poisonous, and most of the time the black nightshade berries are confused with what is known as the dead nightshade, and this is why they are generally termed as poisonous. Therefore, if we do proper research on these edible berries, then we can demystify these and incorporate these berries into the diet. Why do we need to do that? We know that there is a global hidden hunger index. It has been improving over the years, but still it's at unacceptable levels, and especially in the developing countries where we are. And for us in Kenya, the hidden hunger indices are quite high, as indicated by stunting, iron deficiency, anemia, and low serum retinol. So some of the remedies that are suggested include a supplementation and dietary provision of these nutrients, and the AIVs, or the African indigenous vegetables, are some which could be used for this purpose. But as I've already indicated, underutilization of this particular champion, that is the nightshade, is a main concern, and that is what we're trying to address here by unveiling or unleashing the potential that is in the berries. But to do this first, we had to characterize the berries, and this is why this presentation is on the characterization of these berries. So it was to characterize the physical chemical properties of the African nightshade edible berries, and some of the parameters that you analyzed, you had the sugar content, that is glucose and fructose components, as well as the sucrose. And in this case, we used the HPLC method to carry that out. We checked for the firmness using the rheometer, and note that we were checking these characteristics as the fruits were ripening, because we wanted to check these characteristics that are there for the fruit, what is the best harvesting stage, or what is the best level at which they can be attained. So in as much as not present that in this paper or in this presentation, just to know that everything that we'll be doing with the fruits will be checking the progression as they're ripening. So that includes the firmness, the size, and the color. Now, when it came to the changes in the sugar content of these varieties, I found out that I checked for the fructose, glucose, and sucrose content, and realized that the glucose content was increasing as the fruits were ripening. This was also happening in the case of this fructose, but fructose later on reduced when the fruits were at senescence. Now, this could be explained by the fact that when the plants have started the process of photosynthesis, the end product is the sucrose. However, the form of sugar that is transported in the phloem is it's the sucrose, but when it gets to the zinc cells, that is where the sugar is stored, like the berries and others, this sugar has to be converted to hexoses. The reason why it has to be converted into the hexoses is so that they can be, or the sugar can get into various metabolic processes like glycolysis and the like that are required by the plant. Therefore, there is what we call the sucrose futile cycle, whereby the sucrose is converted into fructose and glucose, and then they get into these metabolic processes, and then later on, if when the processes are over, the products again can be converted back to sucrose. That's why we're calling the sucrose futile cycle. So you'll find that there is an increase in this hexoses because there is that conversion taking place. At the same point, there could be an upregulation of the sugar regulatory enzymes like the invertases, and this is what is leading to the increase in these components. you find that this is again supported by studies that have been carried out on the berries. And I may note that the African nightshade berries, this is the first time that they had been given this kind of attention. And therefore it was not possible to compare with other studies that had been carried out on African nightshade edible berries. But research or literature proves or shows that there is this trend in other berries like the strawberries, the raspberries, and therefore this is an acceptable trend. Now, when it came to the sucrose, we found that in the first two stages, we harvested at green, calabric, and ripe, and then senescence. In the first two stages, there was no, the first stage actually when they were green, there was no sucrose content as such. And then at calabric, there were traces, and then it was, there was a spike when they were ripe and then towards senescence. This again could be explained by the very same concept of the sucrose cycle. So in as much as it is there, but it is being converted into these fractions, but there is a component that maybe I didn't look into at this level, and maybe it could be considered as a future study to check the starches, what is happening with the starch, because this could also explain the sucrose behavior. Now, what happened, or the explanation here, is that this increase in the sucrose could be related now to the point where photosynthesis is still taking place at other parts of the plant, but at this point, the berries have matured, and then the sugar regulation enzymes are now reduced, or that cycle is not working anymore, and therefore there is accumulation of this sucrose at this point. Now, we looked at the color changes because we wanted to characterize the various berries. As you saw in the photos, we had some which are orange and others that are black in color. The ones that are orange actually were the black nightshade. And maybe I could have mentioned that the four varieties that we used were, one, we had the giant nightshade, or the ones that you can see here. Carlo Agriculture, this is the variety that is developed by Carlo, and it is marketed under the brand name Agriculture variety. This is what you even find when you have the agricultural shows, and you acquired this from the Carlo Kakamega. Black nightshade and giant nightshade, we got this from similar seeds, and then the improved variety, this work that is has been worked on, or is still being worked on at JCOT. So those are the four varieties, and you find that the black nightshade had reduced L values. Now, L checks for lightness in the fruits, or the L value when you're using the LAB measurements for color. And you'll find that, note that when they were ripening, while the other varieties, the L value was reducing, as well as the A and B values, but the black nightshade, there was an increase in these values, and this was physically visible because it showed they acquired different colors. And again, this showed there is a potential, or there's a probability that there was higher carotenoid content in the black nightshade berries, and this was proven in another part of the study, which is not part of this presentation. So black nightshade, this change in the color, difference in the color, was proven in the qualities that were seen about the nightshades later on. But otherwise, all the other varieties, they had comparable color changes, and they were all black or purplish in color. When checking the firmness, this was done, as I said, using the rheometer. These are very, the size of the berries are quite small, and therefore the pressure was set to penetrate for only 2 millimeters in the berries. And what was noted is that, again, for the three varieties, that is Giant, Carlo, and J-Quad, they were somehow comparable in their firmness, and this was different from the black nightshade, which was significantly different from the others in terms of firmness. They were less hard compared to the others. And the trend that was generally observed was that there was reducing firmness as the fruits were ripening. And again, this is can be explained because we know the physiological changes that are taking place when the berries are ripening. There are polymerization of the cell wall, and the cell wall carbohydrates, pectins, lignins, and the like. And therefore, there is the softening that is taking place. And this could actually explain the trend that you're noticing here, which is also characteristics of other berries. Sizes, as I said, these are quite small berries, and when the size was checked in with the vernier calipers, and the black nightshade again was the least, whereas the giant nightshade had the biggest or the largest fruits. And it was noted that there was no major change in the berry sizes as they were ripening. This was differing from some studies on other fruits, which were indicating that as the fruits mature, then they tend to increase in size. But in this study concerning the berries, no notable change was seen, and this maybe could be due to the varietal differences of the various fruits. Now, when I looked at the conclusions, that when you looked at the sugar content, the black nightshade emerged superior variety compared to the others, and there was changing in the chemical composition. There was a decrease as the fruits were ripening. Then the sugars increased as the fruits were ripening. That is the fructose and sucrose, glucose as well as sucrose. Recommend from this study that edible berries of African nightshade should be exploited as a food item to curb micronutrient deficiencies, because actually this was the whole point of the entire study, to say or to come with the conclusion that, hey, look, here is part of a crop or is a food item that has been neglected. We can use it in one way or another. Then he said, also recommended that alternative value addition methods could be explored as a way of ensuring that the berries can be consumed by an even wider population. Of course, this is based on the fact that the seeds are very small, and sometimes it will be difficult to serve, for instance, adults on these very small berries. And therefore, if you can find a way of incorporating them in the diet in a different way, then that might be better. And actually, this was done as part of the bigger study, and the product was developed and tested for acceptability. Then for further studies, I suggested that biological principles could be explored to develop a variety that produces more and larger berries, because this African nightshade has been highly studied, and modifications have been done to come up with ones that produce bigger leaves and that produce that are less bitter. However, if now we can apply the same principles, after noting that the berries are also a part that can be utilized, then we can use the same principles to come up with those that will produce bigger berries and also produce the plant that produces more berries. Then potentiation studies, they could be carried out so that you can check whether the berries can be incorporated or can be used for other things just apart from nutrition, or maybe in pharmacology by making use of the antioxidant and nutraceutical potential. So thank you very much for listening to me.
Thank you, Daktari, for yet again a very educative, insightful presentation on African nightshade. We take this this vegetable for granted, but you've seen it has a lot of advantages. One is dealing with the hidden hunger, which mostly is about micronutrients, and you've said it has a lot of iron. And then the other one is about low selenium retinol, which it can be a source of it. And it is very interesting for us, especially women, in the issues of iron and the anti-aging factor or agent that can help us not to grow old and still continue looking good. So it's very interesting. And the most thing that you have presented is about the sugars, which most of us use sawdust to energize ourselves, but now we have known berries can do better. So in the field, we can use berries to energize ourselves and get sugars. So thank you so much. I'll open the discussion to the participants. Those who have got comments or questions to Dr. Heka, you can address them now. Thank you. You can raise your hands or you just chat. I can see Violet Osire says, quite an educative presentation. Thank you, Dr. Kamau.
You're welcome. Thank you.
Anybody who has got a question to Daktari or a comment? If none, I will, Dr. Kamau, if you don't mind, I have several questions to ask or comments on your presentation. Number one is that, as I had alluded earlier, that this crop can be used to elevate human hunger. I need hidden hunger, but now I'm wondering, in the berries, did you do characterization? Did you check whether the level of iron, the level of serenum retinol, or something like that?
Yes, looked at that was one of the objectives, and they looked at various characteristics. That was the mineral composition. We looked at all the electrolytes, important ones: magnesium, calcium, iron, zinc, potassium. We looked at all those and how they were changing as the fruits were ripening.
Okay.
We also looked at the phytochemical content. That is the flavonoids, the phytates, the tannins, the oxalates. This was so that we can check the antioxidant capacity of the berries and how it is happening as they're ripening. And maybe if I could mention, even if it is not part of this presentation, is that we noted or recommended that they could be harvested at 2 stages depending on the need or where we need to use the fruits. If you want to the phytochemical content and the antioxidant capacity, then at color break is where the components were reached at that particular point. If it is for consumption now, and where we incorporated it in yogurt and produced berry flavored yogurt, then at the ripe stage was the best, because not only did it increase the flavonoids, but the anti-nutrient components were reduced. So, and again, we also checked the total carotenoids of the fruits, the vitamin C, we checked titrable acidity. So to answer your question, Doc, yes, in the general study, those components were checked and characterized as they were ripening.
So would you recommend that the berries can be used like supplement for iron? And is it possible to get such a supplement from the berries? Because I find it very interesting, especially the orange berry, which is the local one, if I'm not wrong. Yeah, and it's almost extinct now. I used to see it when I was young, and we used just to chew the berries. But the black one, I've never chewed it because I always thought it was not very palatable. So I'm wondering whether we can do a supplement of iron, which is a very big issue in women in terms of our monthly issues there. And then also nowadays we are very sensitive to the issues of anti-aging. We buy very expensive products in the market to reduce wrinkles near our eyes, and I'm like, oh, so we have a savior already locally. So it's something that you would recommend to be done, or do you have an idea? Or are you anticipating to do anything like that?
Yes, maybe I could mention that this study, actually, this is what I did for my PhD. And the idea I had with my team when we were working on this is that concept of continuity. Can we come up with products? Can we come up with ways of incorporating this in the diet? So for now, what we came up with is the yogurt, and we use that as a vehicle because the trend globally is that people are consuming more yogurts, and especially berry flavored, fruit flavored yogurts are becoming very popular. So for now, what we have looked at is that product of the berries. But one recommendation from the general study is that we could look for other ways of incorporating it in the diet. And also the one that I had on this study where we looked at the potentiation, that is checking it for use in the this second recommendation here. So we are checking it's or what can be done to check on the bioactive components and how they can be extracted and maybe put in a drug or a supplement, as they are saying. So we've not yet done that, but it's something that I'm hoping that I can work on later on, of course, with collaborators, and maybe see if we can extract and have such a product, Doc.
Oh, thank you. Wish you all the best. We want these local solutions, and I believe they will be cheap for every woman or every Kenyan or the Africans, because I mean, African nightshade is a local plant to us. So I think it will be a breakthrough in some of the industries that we are looking forward to have in our Big Four agenda. So thank you so much. So unless there's any other question, my worry was about actually on the recommendation, because is it recommendation or conclusion? Because you recommended about hidden hunger, yet this study was about sugars. So I don't know whether it was a got mixed up. Yeah, because the study is about sugars, it's not about micronutrients. So you can check on that. Thank you so much. So unless there's any other comment or question, we'll leave Heka to go on for further research and produce more products for human beings to use. Thank you so much, Heka. So we go to the next presentation. Is Emily Kimayo in?
Yes.
All right, Emily, it is your time, and you're going to present on effect of compositing sorghum with soybean and African nightshade on quality of steve porridge for young children. You're welcome.
Thank you.
Emily, you can go on.
Have you shared my screen? Oh, I'm sharing.
Hello? We've already shared.
Sorry?
We have shared. I hope
have
everyone else
another
can
one.
see.
I have another one I can share.
Oh, so we pull down this one?
Yeah.
All right, thank you.
Thank you. Hello, can you see my screen?
Yeah, put it on full mode.
Okay.
Thank you.
Okay, my name is Emily Kimaya, a student in the Department of Family and Consumer Science, taking my master's in nutrition and in community nutrition. I'll be presenting a paper on the effects of compositing sorghum with soy and African nightshade on the quality of steve porridge, ugali for young children. Welcome. So yeah, young children.
Excuse me, all the other participants, could you kindly mute? Thank you.
Okay, young children are among the most vulnerable groups in developing countries, which are affected by protein, energy malnutrition, and the micronutrients deficiency, which is hidden hunger. So it has been found that most of 26% of the children in Kenya are suffering from protein energy malnutrition, as per the KDHS report. And also, additionally, with the hard of the COVID-19 pandemic, there is need for to provide further functional foods that boost the immunity. So the most significant micronutrient deficiency in young include vitamin A, zinc, and iron. Steve porridge, which is ugali, has the potential to significantly contribute to the fight against malnutrition. And we know ugali is mostly consumed in almost all families, especially during lunchtime and dinner. And the flour, which is normally used, is maize. And maize has been the price of maize is increasing, and the climate change has affected the production of this maize. So we can use other flours, for example, the sorghum, which is drought resistant, and it's nutritionally superior as compared to other cereals. So, however, this sorghum is low in protein content and has poor digestibility. So to supplement the proteins of this sorghum, you can fortify it with the soy, which is available. So ugali is normally consumed with green vegetables, and we found that most of the times during dry season like now, the amount of vegetables that is taken with ugali is limited, and which provide a low nutrient index for the micronutrients, which is found mainly in vegetables. Then to enhance the micronutrient content, we use the high zinc content sorghum by adding African nightshade to increase the iron, calcium, and zinc, and also potassium and vitamin A. So the aim of the study was to develop a premix of brown ugali made from sorghum flour, which is designed to meet the nutrient requirements of young children. Such a product does not exist in Kenya market. It will also have all the nutrients the child needs. Therefore, even if the accompaniment is not nutritionally adequate, the child will still meet the substantial amount of their daily requirement for protein and micronutrients. With the enhanced micronutrient and protein index, and being made from whole grain, therefore added functionality, it will have the potential to give young children higher immunity and protection against COVID. So sorghum and soy were obtained from farmers in Siaya. Fresh cassava was obtained from farmers in a non-farmer in Siaya. And black nightshade, or the African nightshade, sorry, was planted in the University of Eldoret Outreach Center. So the soy, sorghum, and maize grains were each sorted and cleaned to remove extraneous materials. And soy flour was prepared using the method by IITA with slight modification, whereby the soy were washed, dried, and roasted in an oven at 100 degrees centigrade for half an hour, cooled, and then dried. The dry roasted beans, dried cassava, and cereal grains were dried, and dried African nightshade were each milled separately using a commercial miller. So the formulation of the samples were done as on the below. I took sorghum 58%, soy 30%, and cassava 10%, with African nightshade 2%, and another variation of 68% and 100% sorghum. And then I did also a mix of sorghum and maize, 50%, 50%, with the same variations of sorghum, cassava, and African nightshade, and also pure maize with the same variations. So the chemical analysis were done as per the official recommended methods of analysis for the moisture, crude fiber, proteins, and carbohydrates. Oil holding capacity and water holding capacity were also done, and also the mineral content for calcium, magnesium, phosphorus, zinc, and iron were done. So the results were as follows. So the flour which were made, I made a ugali from the flour by using a ratio of 1 to 2 as per the Onyango formula. And then I dried the ugali sample so as to do the analysis of the approximates. And the analysis are as you can see. For the moisture content, it was between 10.15 to 6.17. Moisture content is important for food storage, but then it's not applicable in this ugali because ugali is normally made and consumed when it's fresh. So the crude protein ranged between 20.86 to 0.7, and the high content of crude protein was from the 30% soy with sorghum. 30% soy, 10% cassava, and 2% African nightshade in sorghum variation. The ash content also ranged between 0.28 to 2.95. And we can see the sorghum variation of 30% soy had the highest content of ash. This is because of the probably maybe addition of the African nightshade to the product, the ugali. And then the crude fiber, the crude fats were between 10.95 and to 3.30. And the maize variation of 30% had the highest crude fiber, crude protein, crude fats. And then the carbohydrates, the maize has the highest of 81. And the percentage of the carbohydrates reduced. This is because maybe of the addition of soy, which don't store their food in terms of carbohydrates. They are normally proteins. And then the crude fiber, the sorghum variation of 30% had the highest percentage of crude fiber. For the micronutrients or the mineral content, it was found that the sorghum had the highest amount of magnesium, or the content of grams per 100 grams in dry basis. We also, the zinc also had the sorghum 30% variation had the highest content of zinc, and we used sorghum which had the highest content, and we found that the zinc is very important micronutrient, especially in this pandemic of COVID. Many studies have been done on COVID and relationship between COVID and zinc, and it has been found that zinc can prevent the occurrence of or the severity of COVID, and also prevent the children from getting this disease. And it has been found that zinc has been used to prevent the respiratory tract infections mostly. And it has been found that the recent research have found that most people who get COVID or they are severe to COVID are also deficient in zinc. So iron also had the sorghum variation of 30% had high content of iron, and calcium also, and phosphorus. Water holding capacity, this is the functional property of the flour. I use the flour here instead of the maize or the ugali, which has been cooked. And functional properties are important because they determine how the product will be used. For example, if you see the water holding capacity for the maize, it was 1.32, while the sorghum soy variety of 30% had 1.19, and also the oil capacity also increased when the soy was added. This is because of maybe the soy, which has got high protein content, and it makes the water it makes the flour to absorb more water, and also the oil. And the oil holding capacity helps us, the functional property of the oil holding capacity helps us to determine the texture and also the taste of the product because of the fat content. So in conclusion, we find that the sorghum, which is fortified with 30% soy, 10% cassava, and 2% African nightshade, improved in the protein content of the ugali, and also the zinc and iron content increased as compared to the unfortified ugali. Then with the enhanced micronutrient and protein intake and being made from whole grain, therefore added functionality, it will have the potential to give young children higher immunity and protection against COVID-19. Fortification of sugar of sorghum with 30% soy and 10% cassava and 2% African nightshade significantly improve their water and oil absorption capacities. So on the recommendation part of it, since sorghum have phytates, we can still analyze on the digestibility of protein to ascertain the availability of the protein in this product, and also the phytate content in the product. And I recommend it to be consumed as it's rich in protein and also rich in micronutrients, which will elevate the micronutrient content and also prevent respiratory infections such as COVID. Thank you.
Thank you, Emily, for that interesting presentation. I think you've taken Dr. Kamau's study of African nightshade a notch higher by developing a product that can be used by young children and which improves their immunity, and that is very interesting. I will therefore open the floor to participants to either ask questions or give a comment to Emily. Please, you're welcome. You can raise your hand or just chat at the chat box, and we can see. Any question or comment, please? Any question or comment on, or it was very interesting, you got everything? Yes, Emily.
Yes.
I would like you to go back to your slides on the concentration of the nutrients of the dried ugali. Especially the micronutrients. Before you go to even the ash, you know, not everybody knows what is ash. Can you explain what is ash?
Ash is the what remains after incineration. After you burn the content is what remains after burning.
So it is in grams?
Yeah, in grams per 100 grams dry basis.
Okay. Okay, let's go to the next slide. You're saying zinc is 2.89 grams per 100 grams of cooked ugali.
Yeah.
That's a bit high, considering we apply very little zinc. And this is sorghum, not even soybean, yeah. So I don't know whether it was the right calculation or that's real how it is. What do you think?
I used the sorghum, which was rich enhanced from the field. Then
so how are you getting sorghum alone from? You said this analysis is from cooked ugali, and cooked ugali has both maize, sorghum, and maize. Or you cook differently?
There is ugali with sorghum alone there.
Okay. Okay.
47, and then ugali of 30% there, 10% soya.
So how did you get zinc from sorghum from a cooked ugali that has got soya, cassava, and African nightshade specifically?
Okay. I prepared the ugali with the ratios there, and then I take it to the lab for analysis.
But it's already combined. How would you tell the zinc is from sorghum or it's from maize or it's
No,
from African nightshade?
I've not said sorghum is from the soy as per se. I said the sorghum which I used initially had sorghum zinc enriched.
These are concentrations of nutrients before cooking.
After cooking.
Hey, Emily, you have cooked ugali that has got maize and sorghum.
Sorghum,
and soy.
Soy and African nightshade with cassava.
You cook and dry it.
Yeah.
Remember, it has all these combinations.
Yeah.
Then you dry it, you take it to the lab for analysis.
Yes.
So you cannot put zinc or magnesium on sorghum because it's a combined thing. You don't know where the zinc is coming from. So that's my problem. Yes.
I've not said it's coming from sorghum.
But your data, your table, look at your data.
Okay, okay, it's ugali. Oh, okay, there is ugali there for maize with the micronutrients. There is ugali for sorghum alone for the nutrients and ugali maize sorghum. And then there is ugali for 30% soy, 10% cassava, and 2% African nightshade on the maize, sorghum, and maize.
Oh, so it's sorghum-based ugali.
Yeah.
All right, that is because now you have to put it clearly, because when you say sorghum and you have cooked with combination, it confuses the reader. So you say sorghum-based ugali or something like that, so that we understand. Sorry for that. Yeah, I was wondering now how you differentiated zinc from the composite, but thank you so much for that explanation. But still, I'm worried about the values of
okay, I'll go and check.
Yeah, go and check the calculations actually for all those micronutrients and nutrients. When it's already cooked.
Yeah.
Yeah, please check the calculations. Thank you so much. Did I have any other question, really? I don't think I had any other question. So unless there's anybody else who have got a question or a comment to Emily Kimayu's presentation, then we can move to the third presenter. And that is Benedict Kipkemoy. He will be talking about profitability of green gram, Vigna radiata, production among smallholder farmers in Ikutha sub-county, Kitui County in Kenya. So Emily, you can pull down your presentation and we get Benedict. We have Benedict. Yeah, it's already uploaded. Benedict, are you in? No, he's not there. Okay. We can upload the Lynette's presentation. Lynn Oyimbo. Lynn, are you there?
Yes.
All right, we are uploading your presentation. And Lynn will be presenting on determination of DODA, Kuskuta SPP, host to range diversity in Uasin Gishu County. We'll know what is DODA as Emily presents. Thank you. You're welcome, Emily. You can move on. No, Lynn, sorry.
Okay. I was confused. Okay, in this study, we looked at the determination of DODA, host range diversity in Uasin Gishu County, because when the first time we saw DODA is the plant that you can see in the picture that looks spaghetti-like, does not have leaves. The one that we are normally used to in this part of Kenya is this yellow color, but there are others. There is a green one. There is also a pink one that we'll see later. So we realized that the first time we saw DODA, we saw it along the roads on hedges. and was mostly attacking euphorbia species. But with the time, this dodder was found on other plant species, and that is part of what made us to go out and determine the host range diversity, which plants act as hosts for this dodder. By host, I mean this dodder is 100% parasitic. It needs a host for it to survive. So that is what we did. And it's part of a larger study done by 5 members of a research team. So as I've just said, dodder is a parasitic plant. It's also invasive and comes in very many species. There are about 200 recorded species. And being a parasitic, it threatens food security and environment integrity because it is 100% parasitic, as I said, and whatever it attaches on gradually dies off. So that reduces the biodiversity. And on food crops, if the same happens on food crops, of course, we will have a threatened food security. So the plant lacks leaves and roots. And for most people that we talk to out there, it is a mystery because they are like, we've never seen what we are seeing in our plant without leaves, without roots, that we are not understanding. It occurs as vines intertwining on other plants. It is new in Kenya and is moving very fast, is invasive and occurs in a very wide range of habitats. Literature has very little, at times nothing, on dodder, and it's now making it its control a challenge. When you want to look at any literature on this dodder, you will just find it either on social media or on newspapers, but nothing much scientific has been documented on dodder. Out of the more than 200 species that are known, only 15 to 20 species cause economic damage to crops worldwide. And it has an extensive spectrum of plant hosts, though of the many hosts, monocots are less preferred. Infestation is through stem-to-stem interaction and tissue penetration. So if it will not be able to penetrate the host, then that confers protection to the host. It reproduces both vegetatively and by seed. And the seeds have a very long dormancy period and can be viable for up to 60 years in the soil. Heavy dodder infestation can kill the host plant gradually, but there are some plants that we realized that after attack, they are able to regenerate because the dodder is annual. So after the dodder has dried out, the plant is able to regenerate. But for some, they are not able to regenerate. So we did a survey within Uasin Gishu County in the year 2020 to sample plants that have been infested by dodder. We collected data on the host plant family. Like we have identified this is the host, yes. So we went further. What family does this host belong to? The growth habit of the host, whether it is a tree, a shrub, or a herb. The geographical indication, whether the host is exotic or indigenous to Uasin Gishu County, and the host's plant primary uses, what the plant is used for. Then we did analysis and we reported the results quantitatively. So for results, we found out that Cuscuta species infestation based on a plant family, that a total of 50 plant species were infested by dodder. And of these 50 species, they belong to 28 families. Out of all the families, in Uasin Gishu County, Asteraceae family was the most preferred at 10.6%. So in terms of the growth habit of the host, the highest infestation was on herbs at 39%. No, there is a mistake there. The highest infestation was on herbs Then the next sentence should be shrubs and trees were at 14 and 11%, were at 14 and 11, 14 out of 50 and 11 out of 50, representing 30 and 24% respectively. And there was dodder on trees, but then it did not occur at more than 10 meters high. Vines and climbers were also infested at 4% and 2% respectively. These are the results, the one you can see to the right, the trees and shrubs, herbs, and vines and climbers. So I think there is a mistake. I made corrections. I think it did not, I did not send the right one. Anyway, there are differences in the percentages reported in this. The right ones are the ones that I've just said. And the title is also wrong on those, on that slide. Then there is also host susceptibility based on the geographical indication of the plant, whether it is exotic or indigenous. The observation was that exotic plants were more susceptible to dodder at 62%, whereas native species infestation was at 38%. Based on plant uses, the most prevalent use categories are medicinal. Medicinal plants were infested at 38%. Those that are used at firewood at 21%, ornamentals at 12%, fruits at 9%, timber 7%, fencing materials 5%. The ones used for charcoal, beverage, foods, green manure, and vegetable at 2%. And this is what is shown here. Dodder host uses from firewood to the ones that are used as manure. And to the left, we have natives and exotic plants. The results and discussion continues. Dodder attacks different plants with more intensity on plants with rough stem and leaves. The most affected plants include euphorbia species, lantana species, acacia, and croton species. There were notable incidences that are of a lot of interest to farmers, that there were dodder incidences that were reported on avocado, mangoes, and Solanum nigrum. There were no incidences reported on food crops in the study area. In conclusion, Cuscuta species showed a wide host range in Uasin Gishu County, where the Asteraceae plants are at the highest risk. We recommended that more Cuscuta host range studies to be done so as to advise policymakers and farmers on what plants are at a higher risk than others. And this was driven by the fact that there is a lot of campaign for farmers to adopt avocado production, and we found incidences of infestation on avocado. So that is of interest, that before this avocado production is taken up fully by farmers, we should look at how we can control this dodder. The University of Eldoret and Uasin Gishu County are acknowledged for being of support to the research team. Thank you. Thank you, I'm done.
Oh, thank you, Lynn, for that educative and insightful presentation. Because now I know the name of this parasitic weed. I didn't know what it's called, and I was wondering what is dodder. So, and I'm sure I'm not alone. Many people have got such a lack of knowledge, and so thank you so much. And you have given us insight that dodder affects most of the Asteraceae family, and you have named a few of them. And you've said it's very important on the issue of avocado, although you got very few incidences of infestation of dodder on avocado trees. So it is something that we need to continue working on to be able to control its evasiveness. I mean, it's a parasitic effect on food and food production, which eventually affects food and nutritional security. So I'm opening the floor to the participants to ask any question to Lynn about dodder or any comment towards her presentation. You're welcome. You can do it through raising your hand or just chatting on the chat box. Thank you. Hello? Anybody want to ask a question? Or comment on Lynn's presentation?
Hello?
Hello?
Yeah,
Dennis?
this is Dennis. This is
Dennis,
Dennis.
you're welcome. You can go on.
Oh, thank you. Lynn, thank you for the presentation and the more information about dodder. So many people are now aware that dodder is called Cuscuta. And then I wanted to ask, how many of the economically important dodder species are already available in Uasin Gishu County? And I didn't get the clear relationship among the many dodder species that affect a wide range of crops and plants. So how are they related? Is there any interaction? And then the last question is there a barrier plant against dodder among the many species of dodder that affect the plants that you have come in contact with? Thank you.
Thank you, Dennis. The first question is on, okay, I didn't manage to write. You can please ask one by one.
Okay.
Go ahead, Dennis.
Okay, thank you. So the first question was, I was asking how many of the dodder species among the economically important ones are already there in Uasin Gishu County?
Okay, the species that are already available, we have another study that was presented by Dr. Emmy on the diversity. At first, at the start of the research, we wanted to look at molecular diversity so that we could tell what is already available, but many things did not work the way we had planned. We ended up doing a morphological analysis. So there is another study on that. But majorly we have 3, Cuscuta, Kilimanjari, Cuscuta, Japonicum, and there's a third one that I can get the name if I look at the work that was presented by Dr. Emmy, who was majorly concerned with the morphological analysis. She's done breeding, so she's the one that was looking at that.
Okay, the other question was among the many plants in actually infested by dodder, do they have a common relationship?
Okay, what we found from literature, the literature is very limited, but what we found out is that there must be something to do with their plant cell. Well, because no cases have been reported on monocots. Okay, let's take an example of maize. Maize is not infested by dodder. So what we got is that there must be something in the maize plant cell that is not in these others. So our next, okay, it is a research that has just started, that we plan to take it far to dissect all the aspects that need to be understood about dodder. So that is part of what we want to do. What is it in this maize that is not in avocado plant, for example, that is making it possible for an avocado plant to be infested and not maize. Because at first we were thinking that it was about the lignification of the tissues, but then you find that avocado is more lignified than maize. So that ruled it out. So on that, it's something that we are yet to find out.
Okay, I think the last question is more or less connected to what you have just answered. There was, if I think I've come across the dodder infestations in some other places. I realize it looks a bit jumping on how it infects one area and then another one. So I felt like if you have several trees of different species planted in an area, you realize that a few are infected, some are not infected. So I was thinking that there might be a barrier in different plants, like what you are saying could be in maize.
Yes, we came up with the conflicting issues out here from the literature, and the literature I'm talking about is what has been done outside Kenya. There's nothing completely in Kenya as of now that we've come across. Some researchers are saying that dodder is host specific. I mean, dodder species, the many species that we've talked about are host specific. One dodder species to a specific host. But now other studies are saying that dodder is generalistic. So looking at what you are raising, it looks like the one that talks about dodder species being host specific, working in this hypothesis. Though we are yet to come to that, because we didn't want to pick research that is done outside of Africa. We wanted to have our own data that we could look at. But then even on that is done outside, we found those contrasting information that we will want to iron out by ourselves.
Okay, thank you for the wonderful replies, and I allow others to join in.
Thank you, Dennis.
Anyone else who have got a comment or a question to Lynn? If not, I will mind. I don't know whether Lynn, you have an answer, because you talked about why you did this research. It's about your concern in avocado, but yet in your results, it doesn't look like it's an issue. So should we worry or should we worry not?
Okay, I don't know whether I'm getting you right. Should we worry about the incidences of
yeah,
dodder?
of avocado, yeah, dodder on an avocado, and in your study, which avocado variety was affected? Did you go to that level? Is it the indigenous ones, and they are the ones that are now being promoted, the Hass, the ones that are supposed to be exported? Which one of those, even with the low incidences that you got, was more susceptible? And is the susceptibility level an issue to worry about?
Okay, the avocado species that we came about, okay, we didn't go to look at the species, but I can confirm it is not Hass, because it is those old long-time trees that are very tall. No,
So they're
Hass
the
is
local
not.
ones.
Yes,
Okay.
the local ones. And then now on the incidences, we were working at a time that it was not so much conducive for us out there. In 2020, there were many incidences of COVID that we were not allowed to interact out there so much, because even in the few incidences we got, it is people that we talked to that took us to those places. So that could have limited us. If it were the normal days, maybe we could have gotten many. Then number two, we did it at one time, I can say. We didn't do it over a long period to find out the behavior of Doda, maybe during the long rains, during the drought seasons. We didn't do that. So we do not know the dynamics of Doda given those conditions. So that, and our time was, it was a trying period, and our resources could not allow us carry out the research in different seasons so that we could find out. So why I said is of concern is that now we can now pick on Doda incidences on avocado and cascade it now as Doda on avocado itself. If we concentrate on that, we can come with good findings that can be of help to stakeholders.
Okay, thank you, Lynn. So the study is not yet conclusive in terms of Doda infection on avocado or infestation on avocado. So I hope you'll get funds to continue, because this is quite interesting now that avocado is being popularized in Uasin Gishu or in most of these counties, and we should know the issues that would affect its productivity. So thank you so much. And unless there's any other question, we'll allow Lynn to rest. And we have come to the end of our presentations or our session this morning. It's now afternoon and our session is ending now. And thank you so much for your contributions, being there, even to listen to the presentations and your reactions in every presentation. And thank you for the presenters for their time to be able to present. And I also would like to invite you again in the afternoon sessions. We still have afternoon sessions. This is our last day of our conference. So we have an afternoon session. So you're welcome to join any of the sessions in the afternoon. Thank you so much and God bless you. Thank you.
the material available in our gene banks is quite low. Let's go to the next slide. So what are the conclusions that we could draw from this study? The first one is that the Kenyan genotypes available in our local collection has quite limited diversity. And if we have to improve our varieties, we need to source for more variable materials that can help to enable us get the genetic gain in our breeding programs. And AFLP, the second conclusion is that AFLP actually showed the sensitivity to be able to demonstrate the fact that you can be able to acquire polymorphism from this material, and therefore for analysis of diversity, it is possible. So there are crops with similar characteristics whereby the diversity is very low, and therefore AFLP can form a very important tool that can be utilized to be able to study genetic diversity. And that is the end of my presentation. Thank you.
Thank you, Dr. Are you through, Dr.?
I'm through.
Thank you very much. Thank you very much for your presentation. I think we are just like the rest of the presenters for today. You are very audible for us, and you gave a very wealthy of information based on the area that you are presenting. So thank you so much for the good presentation that you've made. So up to there, members, I think that was our last presenter for today. And for the benefit of members who joined us later, today we've had a number of presentations, 5 presentations. The first presenter was Dr. Chebet, who gave us a presentation on the effect of timing of nutrition, nitrogen application on growth, yields, quality of Irish potatoes, the Shangi variety. Our second presenter was Simon Kimno and other co-authors, who gave his presentation on mainstreaming mutation induction technology on underutilized crops for food security, which was a perspective of Dolikos Laplap. The third presenter was Dr. Amy Chepkoech, who gave a presentation on the evaluations of constraints limiting passion fruits production in Uasin Gishu County, Kenya. The fourth presentation, once again, was Dr. Daniel Chebet, who gave a wealth of information on his presentation on alleviating the salinity stress of a bruscular mycorrhizal inoculation on mangoes. And the last presenter that we just listened to is Dr. Kanya, who made his presentation on genetic diversity of Kenyan cotton germplasm determined by amplified fragment length polymorphism analysis. So thank you very much, members, for the good presenters, for the good presentation you've made. I think this is a very good opportunity for the researchers, for all of us to listen to whatever the researchers have already presented. And it has a very great contribution towards what we are looking at this particular moment: sustainable food security, nutrition, and nutrition security. And that's basically the essence of our conference that will be concluded today. So the next task that we have ahead of us is for all of us to just engage, to ask questions as we get to the plenary session. In terms of time management, we were not very badly off, though we are late for around 15 minutes. And we apologize for that. we may extend each time into after 1 o'clock, that based on how the discussions of the plenary session will guide us. So this is how we are going to tackle the plenary session. We welcome any member to ask the question, whether it is a question attributed to a specific presenter who made the presentation today in the morning, or any other clarification, or even a compliment on terms of what has been presented. So there's 2 ways of doing that. Just raise your hand if you have a question or a comment or a compliment. And for the members who cannot, there's another option of using the chat. You can chat a question as we follow in the chat session. So just raise your hand if you have an issue pertaining any of the presentation that we've made today. The floor is open, members. I'm seeing Prof. Chuodo, your hand has been up all along, wondering if you are around, or that was the hand that you had raised earlier.
I'm around, Chair. I have not left my coat behind my chair. So can I ask my question?
That's good. Go ahead, Prof.
Is he getting me?
Yeah, we are getting you clearly.
Okay, Chair, thank you. I have a question for Emmy. It's passion fruits. She indicated that from her results, many passion fruit farmers are suffering from the woodiness disease. I wonder whether she and her team have looked for ways of combating this disease that is a problem in Uasin Gishu. And then I want to ask Kania about cotton. Cotton is a crop, was a cash crop in Nyanza, Western and Eastern, specifically Kisumu, Siaya, a bit of Homa Bay, Busia, and Kitui. Ever since the rejuvenation of cotton growing, I am not seeing serious expansion in cotton production. Would he tell us what is happening in that sector? Who is actually spearheading the development of cotton in the country? Because Rivertex, that is a major consumer, I am not sure have the capacity to handle the expansion for the production of this crop. So would he throw some light on who and how are we driving the expansion of cotton production? Thank you.
Can I begin, Chair?
Whoever is ready.
Yes, Chair. Through the Chair. Let me answer on cotton.
Yes, go ahead, please.
Cotton production in Kenya. The production of cotton is spearheaded by Cotton Development Authority, CODA, which is an authority under the Ministry of Agriculture. But now considering agriculture being devolved, this is probably the reason why we are having this challenge of expansion. That coordination of production is really a challenge because CODA is at the national level, yet this activity is devolved. So individual county give priority to the production. So a bit of production is going on in Eastern, that is in Kitui, Makueni, because of the interest that those counties are having, especially like the governor of Kitui has had an interest in cotton, and there is some bit of work going on. But in terms of overall now to capture countrywide, it is still, the production, the expansion is still quite limited. So that is what I would be able to say about the production. There was also a question from Professor Kinyua on whether at the present state, you can still be able to use AFLP to analyze cotton based on the current development in the area. So the answer I would say is yes, AFLP, because for this particular crop being tetraploid and having not been explored extensively in terms of determining where these genes are present for specific traits, AFLP is a marker type that explores the entire genome. And the results of that now can be utilized to do specific studies. So for exploratory work, you can be able to use AFLP, and then the results of that can now go into other types of tools that would be able to improve the breeding abilities of this crop. Thank you. Prof. Ochot, I can see your hand is still up.
I think, Prof. Chodo, you've gotten the response. I don't know whether it is satisfactory.
Yes, I have, Chair.
Thank you, Prof.
Yeah.
We welcome any other observation, question. Just raise your hand if in case you have anything to ask our presenters.
Maybe mine is a follow-up of what Dr. Kanya has responded about AFLP. I mean, Dr. Kanya, if you think of all the other conditions that come along with it, the cost, the patenting, I mean, that the AFLP is a patented method. So that's why I asked, would you use it now? And then also what goes into applying AFLP? Would you apply it seeing that they are newer, simpler, easier to apply method?
Yeah, Prof, I agree with you. This would basically depend on the availability. If you had this facility already in your reach, you can be able to use to explore the material, which can now go to the other better tools that can focus on specific trait based in the breeding. But I acknowledge the fact that the cost involved may not warrant to be able to carry out some of these study based on this method. That is what I would say, Prof.
Thanks, that's fine.
Of Miriam Kinyua, I'm seeing from the chat, at least you've asked one of the questions that you have typed already. And there's two more questions that were directed to Dr. Chebet and Amy. And one of the questions asked directed to Chebet is that the mycorrhiza, forgive me for that, use and economics, especially the returns on investment and social and economics on its applications by the farmers in the dry areas. If Dr. Chebet is able to respond to that, kindly look at that and respond, together also with the questions directed to Emia. As Chebet answers the other question, maybe Amy can go ahead and read that question and respond after Dr. Chebet.
Okay, thank you. Thank you for that question. Let me pick it up again. Let me read it again. The question is mycorrhiza use and economics, especially return to investment and socio-economics, and its application by farmers in dry areas. Okay, let me begin with the, I see like several questions in one. Let me begin with the economics. Mycorrhiza actually is very cheap. If you, just to quote a price from Dudutech, a 20 kg, 20 kilo bag of mycorrhiza costs about 2,000 shillings. So that's like that's like 100 shillings. So from the affordability perspective, then it is not very expensive. There's a bit of echo, but it's okay. So it is not very expensive from an affordability perspective. Now, let me move on to return to investment. The recommendation here for the seedlings is that you apply them at planting time, to the pots, at propagation time. The idea here is when you are transplanting the mycorrhiza into the field, then you are taking the advantage into the field. So in that sense, it is like a one-off kind of investment because they will multiply. You are putting in a small quantity of inoculum. Like in our case, we only needed 50 grams. So they would multiply, and when you get to the field, then they'll be able to multiply with time. The only challenge, and that is where the training now comes, is that again, it is very easy to lose the mycorrhiza, being a fungi, through chemical sprays. So you have to be careful on use of chemicals, pesticides, and fungicides. Those will help mycorrhiza that you have applied. You also have to be careful about issues of soil erosion, washing away of the topsoil where the mycorrhiza would be, so that you end up losing them. So in terms of with proper training, then there is a good return on investment. So I would advise that this is a practice that needs to happen frequently. In fact, the example that I gave, the contrast that I gave was with Japan, where the level of mycorrhiza is very high. What they do is that they repeatedly apply mycorrhiza, even through sprinkler irrigation, through watering can. You put the mycorrhiza can, and when you are watering your fruit seedlings around the seedling, if you do it repeatedly, perhaps once a year, then you are building up on the inoculum potential of the soil and drawing the benefits from it. So, and that then translates into higher yield for the crops, because the mycorrhiza will be able to help the crop to access nutrients and also to alleviate the stresses that come that would affect the crops, especially in the dry areas, issues of drought, issues of salinity. Then they would be able to help and also acquisition of nutrients. So those are my responses. I'm hoping, Prof, I could clarify something if something is not clear, but that is what I can respond to. Thank you.
Yeah, that's okay, Daktari. Thank you.
Thank you, Daktari. Thank you, Prof, also for the response. Prof. Miriam also has a question to Amy, where he's asking that Amy mentioned, just like others before, about the gender involvement in passion fruit value chain. And she's asking, do you go into separating the different stages within the value chain to separate the gender roles? That's the first question. And the second question is on socioeconomics of production vis-a-vis other crops. And I think I'm interested with the first question because I also had almost similar observation when Amy was presenting on gender. And he gave a very high percentage on gender involvement, giving over 90% involvement of men. And I was wondering which kind of stage of production is that? Because most of the studies show, and as we know, passion fruit is very labor intensive. Most of the studies indicate that during the production stages or processing of commodities at the farm, the labor involvement for the women tends to be higher. But when it gets to the marketing stage or the benefit, the reward that they get, they tend to not participate a lot. That goes to who benefits from agricultural engagements. So to these findings, we find males dominating a lot. And I was wondering whether it is in the entire value chain of passion fruits production. Maybe Amy, you can respond that in conjunction with what Prof. Miriam has asked.
Thank you very much for these questions. Actually, I was expecting. On the gender roles, when we went to the field, most of the farmers were, of course, if we find a woman or the husband, and we ask them, of course, who owned the passion fruit orchards, of course, they will tell us it's the man or the wife or the husband. And then that's what we could record. And this was in the production, farming of passion fruit. As you have put it, that passion fruit is a labor-intensive crop, especially at the first stages. Of course, most of the farmers also was giving us the estimates, the amount of money you should have at the beginning. And that's why majority of the people who owned passion fruit orchards were men, because it is a labor-intensive crop, and also most of them were also people who are working class, because you need money to initiate or to start this. What was the other question? And then there was another question also on the issue of whether, because by Prof. Ochoa on the issue of passion fruit woodness disease as the main disease affecting passion fruit in Uasin Gishu County. Of course, one of the constraints also that farmers reported were the source of seed. The crop is a bit neglected, and that's why most of the farmers source the seed from maybe their neighbors, or they go and select even in their own farm. They select the seeds, and then now they initiate that as the seed for the next crop, or they source from other farms the best seed which they look, and then in terms of quality. And that's why this crop, when the disease comes, it affects. And if a neighbor has the same crop, it moves into the second, into the nearby fields. And not much has been done, especially in Kenya, concerning the disease. And KALRO have done a bit, but not much in production of the new varieties. So more needs to be done in breeding for especially host plant resistance to combat the disease. I hope I have answered. Thank you.
Okay, thanks, Daktari. I think that is satisfactorily answered, unless Prof. Miriam has something to add on that.
Yeah, thanks, Chair. Amy, thanks for your attempt to answer my questions, but land ownership and production are two different aspects. So I feel that you shouldn't have presented and said that men are the ones who are more involved just because the land ownership is on them. So it would have been good for us to get to know which parts of the value chain, like the way Chair has said, is men more involved, and which part would the ladies be more involved, because it becomes misleading. It was there even on the first day, people were talking about men being seen to be more involved, while actually it's a misrepresentation. Ownership is very different. And that's why for these socioeconomic studies, one must put the social aspect in it rather than just the economics. On the other hand, Amy, you haven't mentioned about whether you analyzed, let's say, production of passion fruit as compared to, because if it is in the Rift Valley, passion fruit hasn't been, especially in the North Rift, passion fruit hasn't been the crop of choice until 2 years ago, 3. So that's why I was asking about vis-a-vis other crops, wheat, maize, whatever. I mean, those other dairy, for example, you know, those enterprises. So those are the two parts that you haven't responded to, but we can have a discussion if you so wish.
Let me respond. Thank you, Prof, for those questions. On the first one, on the issue of gender, the question was not the owning land by men, but whether they were leasing the farm to cultivate a crop or they use their own. So that's a totally different question from the gender. So you're asking, because there are most of the farmers also own land, use their own land, but others lease so that they can grow passion fruit for of course, for production. So we found out that most of the people use their own land, around 54.7% use their own land, irrespective of the gender. And around 30 something use lease land for production. And then on the issue of...
Sorry, Emmy, maybe let me put it this way. You see, if you came and you asked the family, who produces the passion, and the man is there, the lady would have to be really, really daring to say that she does, or even the man would be very, 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 very impartial for him to say it's the woman. Because whether it is being done by the children or by the women, if it is the man who's responding, unless you have a way of filtering, he will say he's the one. After all, the children and the wife all belong to him, and also the production.
I agree, and I get what you're saying, Prof. Maybe, as I said, that even there's times we even found men, and they would tell us, actually, I have no idea about this crop. Let me call you my wife so that they can help you, give you more about the crop. But I get what you are saying in terms of it can be owned by the whole family. The crop can be owned by the whole family. So I think maybe in future we need to involve more of the social scientists so that they can help us more in that perspective.
Okay, okay. Thank you so much, Dr. I think we have a lot to catch up. It is lighting the debate. So, and when we see the time is not on our side. Remembering what happened yesterday, one of the presenters, I think it was Dr. Anastasia, was saying we need more of this, yet we are going almost 1:30. And I think we are too much on time because we understand there is another session that's supposed to take place from 1. Allow us members to, if there is any kind of interrogation, especially like what Prof. Miriam and Dr. Chebet is discussing, this Dr. Amy is discussing, I think we can take the debate further, maybe later on your own time. I'm seeing one hand being raised by Dr. Chebet. Just 1 minute, Dr.
Yes, please. Yes, I to respond to what Amy has said concerning woodiness, the question that was raised by Prof. Chodo. And woodiness actually is a viral disease that is vectored by aphids. So in that case, then the control measures would be to look at issues of control of aphids. The big challenge that I've observed with farmers is that they are very diligent in spraying their crop, but then they intercrop. So they would intercrop with the other crops which they are not spraying, and those are the spreaders. And that is why it becomes very difficult to control woodiness disease. What the farmers need is more information on how to the causes and how to control the disease. So then it wouldn't be a problem. One last comment that I make is that Amy has brought out issues of the other diseases, especially fusarium wilt and the dieback disease complex. These seem to be more serious diseases that are emerging to passion fruit farmers, especially dieback. Dieback is a disease complex that is really challenging. And even for this, the solution is there for farmers. For example, all what they need to do is to apply trichoderma, which is a beneficial fungi that will antagonize, that will actually parasitize on the pathogens that are causing these diseases. So again, what the farmers need is information. All they need is at planting and once or twice in the course of the year to keep adding trichoderma, and they'll be able to wind up on that disease. And then there was a comment from Miriam concerning passion fruit being a relatively new crop, 2 years, like 2 years old. Actually, passion fruit has been a major crop since late 1990s. The only challenge has been these diseases. So they would come in and 20 years. Then after that, they would move to another area and check the disease, and that is why it keeps becoming a problem. Those are the comments that I just wanted to make in response to what Amy has mentioned. Thank you.
Okay, thank you, Dr. I'm told that we need to wind up. We've gone beyond time, but I had only one comment so that we don't leave the comment that have been made in the chat session, and this was addressed to Kimno. Maybe I don't know if we can connect between Okran and Kimno so that you can link up to one another and try to answer that question together. And because of essence of time, you'll bear with us. I think Okran was asking where he was wondering why we think that 33% work of non-seed propagated crop, unlike the 77% of seed propagated crop, could be reasons behind less work on vegetative propagated crop. Just in less than 15 seconds, Kimno, do you have anything to comment on that?
Yes.
Less than 15 seconds.
Yeah, to answer Professor Kinyo's question, this was a researcher-driven study, and I expect that as we advance the accessions to farmer participatory selection, more accessions could be dropped based on farmer preference selection, because farmers have their own traits they would want to have in their crops. To answer Okran's answer, mutation induction, the starting material should be quite high. We need a higher population, and therefore one of the reasons why we have the seed propagated material taking 77% is because it is easier to handle. It is easier to handle large numbers of seed propagated material than vegetatively propagated material. Also, the technicality of selection after induction. It is easier to raise seed propagated material than the vegetatively propagated material, because vegetatively propagated material may require an extra facility like a tissue culture laboratory to raise that required population. Thanks.
Okay, thanks, Stephen Kimno. I think up to that moment, we've reached the end of our presentations for today. We'd just like to commend the presenters. Congratulations for the good work that we've done this afternoon. I think that was so informative, and this is the way to go in terms of sharing our research findings, which we expect at the end of the day to make an impact in our societies with regard to the productions of food commodities in the agricultural sector and addressing the issues of sustainable and food nutrition security for our country. So thank you very much for the good presentation.
Good afternoon, everyone.
Good afternoon.
Recording in progress.
Good afternoon again. My name
Good
is
afternoon.
Monica Yator, and I'm going to present my paper on the effect of formulated ration on milk quantity and quality among lactating cows. This is a project that I did it in Kitale, Western Seed Company, and it is about a ration which was formulated for dairy milk production. On my introduction, we all know that agriculture contributes a lot in our country, and it actually contributes around 26% of the GDP and 25% left in the livestock subsector. Without saying much, we all know that most of the small-scale dairy farmers actually produce a lot of milk, and most of the towns and even the country depend on their milk. Concentrate supplements help meet the dairy cows' high demand. So let's go to the statement of the problem. Seed companies produce huge byproducts which are often destroyed. These byproducts can be useful animal feeds when mixed with other feed materials to improve their nutritive values. So actually, before we did this research, in the company, the seed company, there is a place which had been set just to put this waste. This could really become a huge mountain waste, and it was occupying a lot of space. So there was need to formulate a diet which we could use this otherwise waste and make it as a dairy feed. Dairy farmers face the challenge of high cost of feeds and other inputs. There's also the issue of poor quality feeds, which significantly reduce net returns from the dairy business. Let's go to justification. There is need to utilize byproducts from seed processing companies to formulate feed rations that is affordable and nutritious to increase milk yield. In Kenya, 77% of dairy cattle are kept by small-scale farmers, and 80% of milk in Kenya is from them. Feeding of dairy cattle is often based on crop residues, low-quality hay, and pasture, which is often low in protein and energy. So you find that most of the farmers, they will try to feed the animals, but maybe they may not be getting the quality feed which can increase their milk production. Now, my broad objective was basically to formulate a diet using this waste from the seed company and other seed processing byproducts. So that is my broad objective. And my specific objective is that after I formulated this ration, I'd want to determine the nutritive value of this formulated diet and other commercial diets that are available commercially. And after I've formulated around and I've checked, I wanted also to compare the performance of this formulated diet and 3 commercial concentrates on milk yield and quality of the cows that I used. Now, my hypothesis in this case is that there are no significant differences on the nutritive values of the formulated and the commercial diets. And the other null objective is that there are no significant differences on the milk quantity and quality when cows are fed on the formulated and commercial diets. materials and methods. The site was at Kitale, Calro Center, and also at Western Seed Company in Kitale. And the experimental design that I used was a Latin square. We also took the data and we analyzed using ANOVA, and we also used 2 keys tests, which we were using to separate the significant means. So first, we formulated the diet, and this formulation ration was done using trial and error method and standard nutrient feed composition table with the support of computer software. So these ingredients were then mixed using a feed mixer, and then it was packed in 70 kilogram bags. And this feed that we formulated, we labeled feed Y. The nutrient analysis was also done on this feed to ascertain the constituents and the components of this formulated ration. So the ingredients that we used to formulate this diet, which we have coded Y, we actually used maize on cob, which are the main lines. We also used molasses, and that is the quantity or the composition. We had sunflower hulls. These were actually the wastes that were at the seed factory. Then we had the soybean cake. This one we bought commercially. Then there was the soybean waste, which was at the seed factory. We had cotton seed cake. We had some mineral, that is Maclick super. We had limestone and premixes. That made our 100% diet. Then we sampled the commercial diet, which we were using it to compare now with this formulated ration. So we had 3 commercial feed types, which we identified based on the frequency of the purchase and the availability in Western region. That's around where Western region was. And then we bought them straight from the manufacturers directly. This was done in 2 batches at an interval of 2 weeks. So the 2 batches from each manufacturer were mixed together for uniformity, and a sample was collected for nutrient analysis. The 3 commercial diets were coded W, X, and Z. So we now have our 3 different commercial diets. And then these animals, we had a basal diet, which we were feeding them with, and their main basal diet was napier grass. And this napier grass, we cut them fresh as a fresh feed, and we chopped them into 2.5 to 3.5 centimeters using a chaff cutter. A sample was picked from the chopped napier grass for nutrient analysis. Now this sample, or this basal diet, we coded it C. Then we now wanted to know actually the nutrient composition of each of these 5 feeds. That is the 3 commercial diets, the formulated diet, and now the basal diet. So we took the samples, then we oven dried them at 65 degrees centigrade for 48 hours so that we remove the moisture. Then the samples were then subjected to analysis according to the methods described by AOSC 2008. Now, coming to the experiment now, we now wanted to evaluate the milk from the cows fed on the formulated and the commercial diets. So we had 5 dairy animals under 5 by 5 Latin square arrangements. This trial actually was to evaluate the milk yield and quality from cows fed on the dairy rations, that is the W, X, Y, Z, and C. So these cows were at the same stage of lactation and actually not a wide range in milk production. Then we preconditioned these animals for a period of 7 days before we started our, before actually taking the data. Then we were feeding them with the same basal diet. We also provided them with clean water and also minerals at 100 grams of mineral supplementation daily. Now, the supplementation level for each of the treatments was 0.7 kilograms per liter of milk produced per day on the lactating Frisian cows. The control cow, we actually fed the basal diet only, which we had coded C. Then the data on milk yield was taken twice, that is AM and PM, during the milking. And the cows were actually observed for their health condition, the vigor and vitality. So the milk samples were taken weekly for quality analysis. On our results and discussions, this is what we found. We have the 5 diets. We have the dry matter, as you can see, the crude protein in each of the 5 diets, the NDF, that is the neutral detergent fiber, the acid detergent fiber, and their ash. So Y is actually the formulated diet, and as you can see, it is actually competing with the commercial diets that were available. But when you look at diet C, which was actually the basal diet, it was a little bit low in most of the components. So as you can see, our diet Y, we actually formulated from the West at the seed company, which were otherwise could have been destroyed and gone to waste. But now we have formulated a ration which is actually competing with other commercial feeds, which are equally the same when you look at the quality. So it really tells you that these other commercial diets, what they are using is not far from what our ration is. So meaning that our farmers could actually get this particular feed cheaply, and their animals can increase on production, therefore increasing their profitability and source of income. Let's continue up. So the basal diet Napier grass had the lowest level in crude protein, and the basal diet was within the nutritional level as other Napier varieties in Kenya, according to Mukisira et al. 1989.
Monica, please, please
Yes?
wind up. Please wind up because we are running out of time.
Yes, please. Can you move up? The effects of the formulated and the commercial diet is, as you can see, that is the milk yield. You can see the formulated diet is also competing well with the other diets. It's giving us 5.27, and the other one, which we were seeing as it was actually giving us highest, was 6.15. Let's go up. So you can see there was a significant difference in the milk production in all the supplementary diets compared to the control. And those fed on the basal diet only had the lowest milk yield. And this was due to lack of additional nutrients from the milk, from the concentrates. On the milk quality, there was no difference, as you can see. there was no difference in the quality of milk. So on my conclusion, please go up. On my conclusion, there was an increase in milk yields in cows supplemented with the diets. That's all the diets. And the formulated diets also, there was an increase in milk yield. There was also no significant difference in the milk quality for all the cows fed on the 4 diets. Recommendation, it is good to supplement pasture and haze with concentrates to actually lactating cows. This was seen when we fed the basal diet only, the production was low, but when you supplemented, the production became high. Seed companies can use the seed processing products to compound feed for dairy industry. And actually further work can also be done on this particular formulated diet basing on different feeding systems. Thank you.
Thank you. Thank you, Monica, for that good presentation. Now I'm going to open the floor for questions. Please, if you have any question, just unmute your microphone and go ahead or raise up your hand so that I can be able to see you. Any questions for Monica, kindly? Any questions for Monica? Okay, Monica, maybe you can just a quick one from me.
Yes.
So you use different for the formulation of the different rations, so that you ended up with having 5 of them. For example, you use different sources, that is maize and the other materials. My question is whether you did an analysis of these materials, for example, the maize, to be able to know exactly what % nutrients they are actually contributing to the final ration. Maybe just an insight on that. Thank you.
Okay, based on the standard tables, maize, there is a standard nutrients component of each and every component. But also we went further and we did that. We did analyze component. Sorry, there are some disturbance, Chair. I don't know whether I'm audible enough.
Yeah.
Hello, Chair.
Hello. Yes.
Am I audible?
Yes, we can hear you. There. Please.
I'm also hearing you.
Please mute. Call admin. Please mute your microphone. Monica, please.
Dr.
Yes.
Yeah. So I was saying that all
yes,
the
yeah, we can hear you.
each and every
we want the second presentation.
Yeah, each and every component we analyzed. We did the analysis before we mixed, and then we now did the whole, when it is whole, the formulated diet, we now analyzed it.
Okay, thank you. Thank you very much, Monica. Thank you very much. Thank you very much for a very good presentation and the insights into the ratios that you presented. At this point, let's just go to the next presenter. The next presenter is Biama. Biama, are you there? Biama Philip. Please, are you? We are going to upload your slides. Biama Philip, if you're ready, are you there? I saw you somewhere. Yeah, he's there. Biama Philip, you're the next. You're going to present on factors affecting maize open among smallholder dairy cattle in each county. So the floor is yours, Biama. Kindly take 15 minutes, not more, because we actually are not good in
Hello, Abigail.
terms of time. Thank you. Go ahead, Biama.
Abigail, please.
Yes, Prof.
Hello.
Yes.
I would have liked Monica to indicate to the seed waste materials that she was using.
Okay, Monica, please note that question, and then you can be able to respond to it after Biama has presented. Thank you, Prof, for that. She will respond to that. Biama, please go ahead. Biama, please. Floor is yours.
Unmute.
Emma, are you there? I saw him. Philip Biama, are you there? We can't hear you. Is microphone on? Hello, Philip Biama. You are there. Your phone is on. Can't hear you.
Request him to unmute.
I think he's already unmuted. We cannot hear him. Biama. We give him a few seconds to sort out his microphone. Meanwhile, you can go to the third presenter. Let's go to the third presenter, please. Eric Misiko. Eric, I saw you there. Kindly, please get to the floor and do your presentation.
Yes, I'm there.
Thank you, Eric. Let us load your presentation. Eric, please just take 15 minutes or less if you can, because we are not very good in time, so that we can give you enough time to respond to questions.
Okay.
Are you having it? Just a minute as they load your presentation. Manuya, that one, yeah. Yeah, that one.
Okay, can I start?
Siko, you have put your two gadgets on at the same time. We will hear a lot of echoes. Switch off one, please.
Yeah, I've switched it off.
Unmute one of them. Mr. Misiko, kindly unmute.
Hello, can you get me now? I've unmuted.
Bring to your, it's more of it is about creating awareness, and I will be very happy if we can listen carefully to my requests. This work I did with the supervision of Professor Musalia of Chuka University and Professor Kuria of University of Nairobi. Next. Yeah, the topic is knowledge, attitude, and practices towards paratuberculosis in cattle and sheep in Kericho County and Konoin sub-county of Kenya. Paratuberculosis is a disease also called Jones disease. And I was looking at how it is affecting cattle and sheep in what used to be Kericho district, but after the counties came, it was now Kericho County and Konoin sub-county of Bomet County. The disease is characterized, it's a fatal, chronic, debilitating disease characterized by voracious appetite, profuse projectile diarrhea, and irreversible gradual body depreciation and reduced production. It is caused by the bacteria, Mycobacterium avian subspecies paratuberculosis. This is the typical shape or picture of an animal that is going down with Jones disease. Next. The clinical signs are, please, let's show the photos, please. The clinical signs are as shown there, a voracious appetite. You can see the animals are feeding, yet they are depreciated. And the sheep on the right, you can see diarrhea, and the cow, profuse diarrhea. So that is the picture of what goes on with the animals. Next. The disease is transmitted in feces. The bacteria come out with feces of animals, and therefore it's transmitted through ingestion of water or feed that's contaminated. Or it is also, it comes out also through the milk, and therefore there is vertical transmission to the calves. But calves also get the disease by suckling udders that have been contaminated or made dirty by fecal material that is that has the bacteria. This disease is not easily identifiable in the field because of its slow, gradual progression, and there is no effective antibiotic treatment to it. So this is the area of my work. As I told you, it is the former Kericho district, but now it is Kericho County and Konoin sub-county of Bomet district. Now, the methodology, I randomly sampled or randomly selected 423 households, which are represented by these dots, which were put here by GPS. And I gave to each household a structured questionnaire, which they were supposed to answer questions that would help me know their knowledge, attitude, and practices towards paratuberculosis. I also held 8 focus group discussions in each of the 8 sub-counties, and I also held interviews with veterinary practitioners, agrovet attendants or owners, veterinary laboratory Kericho, medical doctors in 5 hospitals in the area of study, and also the director of veterinary services in Nairobi. The data was analyzed and presented mostly descriptively. Next. So the first question was about production systems, and I found that 95.7% of the farmers were keeping. The 95% of cattle were reared in mixed farms, and by mixed farm I mean a farm where there is both animals and plants. And all these pictures depict that there is animals and there are also plantations, there are other plants within the same farm. Next. Now, this is what semi-zero grazing is to the smallholder farmers. They tether an animal, they allow it to eat the grass as far as the rope can take them, but they also sometimes bring some feed to supplement the animal where it is tied. Next. So these are some of the questions I asked them, and they would answer. In this particular question, I gave them several choices, and I told them to put a tick in any of them so long as it applied to them. So I asked them, why do you keep livestock on your farm? And 96% said because it's a source of income, and a similar number said it's a source of food. For instance, the milk and the eggs, and even the meat, and so on and so forth. So that showed me that livestock on the farm played a very important role. Next. The other question I asked, and I told them to rate it in order of importance, with 1 being the most important and 5 being the least important. I asked them, what income in the household does livestock play? What position does income from livestock play in the household? And you can see sale of milk was the highest, and then sale of sheep, and then sale of cattle, and then sale of others. But at number 2, you can see sale of sheep also played a very big role, and so on and so forth. So sale of milk and sale of sheep were very important to the farmers. Next. Then this disease, as I said, it is characterized by profuse diarrhea. And I also got to know in the questionnaire that they, as you shall see ahead, they confuse helminthosis. Helminthosis is minyoo, kuhara sababu ya ng'ombe kukua na minyoo, and the diarrhea. It's difficult to know which diarrhea is of the disease and which diarrhea is of minyoo. So I wanted to know what is the role, what is the importance of minyoo or minyoo in the farms. And I found those who said it is most important were 6.4%. That helminthosis is most important in 6.4%, and second most important was 16.1%. So that gave me a hint that helminthosis, which to me I interpreted as diarrhea generally, was a big problem in the households. Next. Then another thing, as I told you, transmission is through suckling by the calf, either drinking the milk or suckling, getting from the udder. So I asked them two questions. How do you milk your cows? And you can see 91.6% said manually with suckling. And when I asked them, how does the calf get its milk? 93% said through suckling. So these two questions, I just wanted to go about them to get the real answer, and you could see 91.6 and 93 answered the same. To me, they answered the same issue of importance of calves suckling. Next. And that is the typical picture in the farms. This animal, we had confirmed it to have John's disease, and you can see below the jaw, it is emaciated, and yet the calf has been left to eat, to suckle the way it wants. Meanwhile, the calf is also getting the disease from the mother. Next. There were other questions I asked now, because you remember I said the pathogen comes out through the feces. So I wanted to know, what is the relationship between these people and the feces of the animals? So I asked a question, how do you dispose the livestock manure? 300 out of 423 said they leave it in the pastures. A big number said they use it to refurbish mud houses. A big number also said they apply it to non-pasture crops after heaping, like Napier, like the bananas, and so on and so forth. But this is after heaping. There were other options also they gave, but those three to me were the most important. Next. You can see an example of a farm where they left the feces in the pastures. And this is the same pasture. This pasture also shows you it is overgrazed, and it's overgrazed by the same animals which are who are producing the feces. And if it has the bacteria, they are just getting it directly from the pastures again. Next. Now I wanted to know, what knowledge do they have about the disease in itself? So ask them, is diarrhea a frequent clinical sign? That 7% said for cattle, yes. For sheep, 16. What do you think is the cause of the diarrhea? 52% said anytime they see diarrhea, they think it is the pasture. There's diarrhea coming from the pasture. 27 said it's because of minyoo. Others said infection and others. When I asked them, how do you confirm the cause of diarrhea? They said 58% said they had experience. 36% said they call in the animal health provider who tells them the cause of the diarrhea. And only 2.2% take the sample to the laboratory to get confirmatory diagnosis. Next. The other question was, what is the treatment for diarrhea then? They said you use anthelmintics, which means dawa ya kutibu minyoo. 53 said that. Change the grazing ground, change of feed. So the bulk of them, and some even said antibiotics, which means they thought ng'ombe ikihara imechafuka tumbo because of bacteria, which is true, but paratuberculosis does not have treatment. Okay. Then other clinical signs that are associated with the diarrhea. Anytime you see the diarrhea, what else do you see? They said gradual reduction in milk yield, 59%. Starry coat, gradual emaciation, Now, this number 1 and number 3 are what are associated with Jones disease. So they saw it in their animals, but they did not know that it is Jones disease. Next. This is the kind of diarrhea that the animal, projectile diarrhea. This animal, from here you can see, it was actually lying down when it released the diarrhea, and it shot it that far. So the diarrhea is very projectile. But I asked them, how do you manage chronic diarrhea in your cattle or sheep? 55% said they do nothing. They see diarrhea, but wanawacha tu, hiyo ni hali ya ng'ombe. 24% or about a quarter said they cull the animal, they sell it away, which is the right thing to do for an animal that has persistent diarrhea. And then others say they keep on giving new drugs, they change the veterinary personnel, they change to new anthelmintics, and so on and so forth. Next. Imagine this is a cow that has Jones disease, but it is in its early stages. And it is very healthy. Nobody can ever convince you that this is a Jones disease case. And this farmer had bought it from one of the established farms where it used to give 40 liters, but now it was giving 20 liters, which to this farmer was a lot of milk, because he was buying his animals were giving 5 liters. So when he got one of 20, he was very happy, but he had brought Jones disease to his farm. Next. So some of the conclusions or deductions I made from this study were Jones disease is poorly identified and understood despite the losses it causes and the potential danger it poses as a zoonotic disease. There is no specific local name given to the disease, and that is a sign that it is not known. Majority of the farmers take the diarrhea to be due to helminthosis or other causes. Manure is either left in the pastures, used to refurbish mud houses, or applied in the pasture, and all these exacerbate the spread of the disease. Calves are allowed to suckle almost 95%, and that is also a good way of infecting the calves. Next. So when I also interviewed the other resource persons, the animal owners and keepers, their attitude or some of the practices they had were customs and traditions made them to do some things on the farm, like keeping animals for sentimental purposes or for dowry and all that. Production systems they chose, sentimental attachment. Others thought they knew how to keep animals because they have always had animals on their farms, and yet they kept on doing the wrong thing. Then others went even ethno-veterinary or traditional medicine. Next. The interview to the government people, I got information that the disease is not a priority because nobody talks about it. There is also political correctness. You try talking about something that is happening, but if you talk about it in the wrong forum, it might mess you up. So they keep quiet sometimes. And then there is also the fear of losing trade or business if the disease is known to be there, yet if it is officially announced to be there. And then there's poor veterinary extension services. Next. When I asked the professionals, they confess that they usually confuse the clinical signs in the field. The laboratory services are poor, both veterinary and medical. Paratuberculosis is too slow and difficult to deal with since it has no treatment. And for the unethical professionals, they even thought such a disease is good for business because they keep on treating, no disease, no progress, but they get money for the treatment. So my recommendations were engage the policymakers with facts and justification. And there is a paper I presented in the morning, which now gave some basic data which the policymakers should have. Provide funds and facilitate for research. Spread awareness. To me, this is the most important. These diseases are known to everybody, and it needs to be awareness needs to be created in any way and in any forum. Finally, last slide. I want to acknowledge University of Eldoret, my employer, Nacosti, who partly funded the research, the Director of Veterinary Services, and the Rift Valley Regional Veterinary Investigation Laboratory, Kericho, where I did the work, and Chuka University, which hosted the research. Thank you very much.
Thank you, Dr. Omega, for that very good presentation on the that you've given. It's very enlightening. So at this point, I'm going to open the floor for questions. Any questions for Dr. Omega? Please, if you have a question, raise your hand or just unmute your microphone and go ahead. Any questions for Dr. Omega?
Hello?
Yes, yes, Prof, go ahead. Yes, go ahead, Prof.
I would like to, Dr. Omega, to indicate how long this bacterium can last in the feces or in the soil before it infects another animal. How long would it be in the feces or in the soil? Yeah, before it's transmitted to another animal.
Thank you very much for that question, Professor. This bacteria, first of all, the incubation period is 2 years. So those calves you see suckling, you will never see them with the clinical signs until when they are old enough to give birth. Number two, that bacteria, because of it has some very special lipid structure on its body, on the cell wall, which makes it to be very resilient and hardy in the ordinary, for as long as it's remaining in the fecal part, it can stay there for up to 9 months.
Okay,
and all that time it is infectious.
Okay, thanks.
Thank you, Omega, for that response. Any other question? One more question. Anybody with a question to Dr. Omega? Yes, Philip, you have a question for Dr. Omega?
Dr. Omega, if this disease is that will be considered as a zoonotic disease, that's a disease can affect humans and animals.
Pardon, Philip, a question? Please kindly repeat.
I'm asking Dr. Omega whether the disease is considered as a zoonotic, can affect human and animals.
Yeah, thank you. This disease or this pathogen, there is a disease in humans called Crohn's disease, and the signs are almost the same as the ones I've described here. But the problem is it has been found in 90% of people who are suffering from Crohn's disease. But you know, for a zoonotic disease is a disease which is transmitted from animal to man, which should be 100%. So because 10% of people with the Crohn's disease don't have the bacteria, it is difficult to say it is truly zoonotic. But because of the fastidiousness of the bacteria, a lot of research is ongoing to find out maybe it is not diagnosed in the 10% for some various reasons. And when those reasons will be found, then it will be declared zoonotic. But as at now, it is treated as if it could be zoonotic, but nobody wants to say directly that it is 100% zoonotic.
Thank you.
And indeed, when I talk to the medics in the 5 hospitals, they said very many people come suffering from diarrhea, chronic diarrhea, which is resistant to antibiotic treatment and all that, and many of them die. But they could not diagnose. None of them knew about this mycobacterium, so then they just thought it is other things like amoeba and all those other things. So this disease is also poorly known even among the medics.
Thank you, Dr. It looks like a very interesting study over there, and is, eliciting very many questions. For those who have got more questions, please see Dr. Omega after or over a cup of coffee. I think let's go to the next presenter. The next presenter will be Josephine Barasa. If you are there, please. Then we'll come back to Philip and Eric. Josephine Barasa, are you there?
I'm ready.
Josephine, kindly unmute. Yeah, thank you. Go ahead, Josephine. Please take 15.
I'm ready.
Yes, go ahead. Please take 15 minutes, not more, for your presentation. Thank you.
Good afternoon, everybody. I'm
Good afternoon,
Josephine.
Josephine. Yeah.
I'm Josephine Baraza. My co-presenters are Julius Ochodo and Sifilin Kebene. Move on. The background of my study is soil fertility improvement of the low soil fertility within the tropics and specifically in Western Kenya. To start with, declining and low soil fertility and its effects on crop production threatens food security situation in sub-Saharan Africa and Western Kenya in particular. From the literature, 40% of soils in the tropics are low in weatherable minerals, that is less than 10%. 25% of the soils suffer from aluminum toxicity. These are majorly acidic soils. And 18% of these soils have high leaching capacity, meaning that they cannot hold water. And so they're not able to hold any nutrients. Move on. And why are these a problem? Why is low soil fertility a problem? It is a problem because it leads to low crop yields. And when you have low crop yields in the fields, this one translates to starvation within the households. When the starvation is in existence, it leads to malnutrition. And at the same time, given that smallholder farmers depend on farming as a source of income, there is low farm incomes. And at the end of it, we have got slow rural development. Let's move on. And somebody can ask, what are the causes of low soil fertility? In the first place, farmers practice poor soil fertility management practices, including continuous cereal monocropping. And given that most of the monocots are heavy feeders, they drain so much the inherent soil fertility with none or minimal fertilizer use. And this leads to continuous nutrient mining, leading to impoverished soils. And though we have the problems in existence, farmers have got their own ways to address this low soil fertility pandemic. The technologies in place include inorganic fertilizers that have always been there. These inorganic fertilizers, they have got their own pros and cons. In one way, they are expensive to farmers. The recommendations don't take into consideration the affordability by farmers. They also cause nutrient imbalances when they are applied in excess. And in the long run, they lead to depression of soil productivity, which leads to low crop yields. Move on. We also have the organic inputs. Organic input application have been done by farmers from the time immemorial. Though they have got low nutrient contents, in a way they have got their own advantages, such that they can be able to improve soil physical and chemical properties. They can be able to supply nutrients over time. But at the same time, a farmer cannot be able to synchronize the nutrient release and the high demand for the crop. So at the end of it, we find that sole use of organic fertilizers is not as profitable. We move on. And so what is the way forward? The way forward could be to combine the two fertilizer sources, because for one, the inorganic fertilizers has got the advantage of timely release of the nutrients to the crop, especially at the time when the crop needs it most. And over time, we shall have this, the nutrients being released slowly by the organic inputs over the entire growth period. And at the end of it, we shall find that the crop does not suffer any deficiency, and that one may lead to high crop yields at the end of the day. And at the same time, given that the inorganic fertilizers are very expensive, an example is this year where we are having the highest prices for these inputs, which is a threat to farmers. So if farmers are able to embrace this technology of integrating the two sources, maybe that one may ease them the stress of spending too much on these fertilizer inputs. We move on. So what are the outcomes of such interventions? At the end of it, when we have got balanced nutrient levels within the soil, we can be able to plant anything. So that means that we shall have a diversified and high crop yields. We shall have food security because there is enough from the yields. Nutritional security, because when you feed your crop on a poor soil, you'll end up with a poor crop. And the inverse is true. And the excess of it from the high yields may be sold for an extra coin. And at the end of it, we may have reduction in poverty levels among the smallholder farmers. And so my specific objective for this study was to evaluate the effect of farmyard manure and mavuno fertilizer and their combination on selected soil chemical properties and sorghum grain yields. Move on. Under the methodology, the study
Josephine, kindly trying to hasten your presentation, please, because we are running out of time. Thank you.
Yeah, the study was carried out in Busia County with the given climatic conditions in two sites, that is Busia Township and Teso South. We move on. Move on. That is the map of Busia County. And then we move on. Yeah, that is the field layout. It is a split plot and completely randomized block design. And under this presentation, I'm not going to deal with the intercrops, but I will only deal with the averages that are accrued under different inputs, that is mavuno, farmyard, and the combination for the sorghum crop, not the intercrops. We move on. We move on. The fertilizer rate application was based on P levels, that is 26 kilogram P per hectare for each source. And for the intercrops, I said I'm not dwelling on it because it is not within the paper. It is just a layout. We move on. That is a split plot in completely randomized block design. We move on. Yeah, soil sampling in the field was done based on the procedures by Okalebo Manuals 2002. And given the time, I won't go into the details. We move on. Those are the Okalebo procedures, laboratory methods that were used in the lab experiments. We move on. Determination of crop yields. The samples for yield determination were harvested from the effective area by discarding the outer rows. And the estimation of the grain yield was done based on the formula that is given. We move on. The results. Under the results, the selected soil parameters are the pH and the available P. We find that all the treatments applied, they were significantly higher than the control. The pH in both the present year of treatment application, that was in 2016, and then the 2017 was based on the residual effects of the inputs that were applied in 20 16. The same happened to P availability. And I can say that the materials applied were Mavuno, fertilizer, and organic manure, either singly or in combination. And what I can say that is that the high pH levels could be attributed to calcium lining effect from Mavuno fertilizer, and that one having an improving effect on soil pH could have contributed to the improved pH levels. And then the farmyard manure. Farmyard manure is known to have high CEC and high powering capacity. That one could have contributed to stabilizing of the soil pH. And when the soil pH is improved, that one leads to availability of P. When you look at the next table on total N and organic carbon, can say that the N content from farmyard manure and farmyard manure plus Mavuno combined remained higher compared to Mavuno and control. And this means that the materials applied, they were effective in improving the soil parameters, including the nutrient contents that are being observed. When you look at the organic carbon, these levels generally remained low, and this could be attributed to low soil inherent organic residues, because our soils are known to be low in organic residues, and so that could be the case. And then Western Kenya, due to high temperatures, we find that when the temperatures are high, this leads to rapid decomposition of organic matter into similar compounds that could easily be taken up by the plant or be lost through leaching. And then you also have termites in the area that can feed on the crop residues, and this leads to low organic matter content in the soil. We move on. We have the soil grain yields emanating from the inputs applied. We find that when looking at the result of 2016 short rains, we find that somehow the materials applied gave a significantly higher crop yields as compared to the control, meaning that they were effective in raising the soil fertility, which enhanced the crop yields. The same similar results are in 2017, but higher than 2016, because what we realize here is that for both sides, the yields for 2017 were higher than for 2016. The reason could be, one, during the 2016 season, the rains were not sufficient, and also maybe the inputs could not have been undergone mineralization. And so over time, these inputs were able to mineralize, and even the higher rains that were realized early in 2017, they were able to be availed to the crop that may have contributed to high crop yields in the present year, in the following year of the manure applications. We move on. Conclusion. As I conclude, I can say that low soil fertility is one of the main challenges affecting the efforts made by farmers towards achieving surplus food for ever escalating population, and particularly in Kenya. And continuous cropping, on the other hand, with the sole reliance on chemical fertilizer sources, is among the cause of gradual soil fertility depletion. However, the integrated use of organic and inorganic fertilizers could help to avert such soil fertility related problems and lead to soil fertility improvement. Furthermore, this can increase the production and productivity of continuously grown crops and hence address the food security problem. Move on. Recommendation. Dakari, yeah?
Go on, Josephine.
I'm through with the conclusion.
Okay.
The recommendation is either organic or inorganic inputs are recommended for the improved crop yields, but for sustainability of soil fertility, the two inputs can be profitably be done by farmers to be able to reduce on the cost that they normally spend on the inorganic fertilizers. Next. Can say thank you for giving me the chance to present this paper. And so that's the end. God bless you.
Thank you so much, Josephine. Yeah, so of course, being a soil scientist, I have a lot of interest in your presentation, but let me just give an opportunity to the floor to ask questions. Any questions for Josephine's presentations, please? Kindly, one or two, before we move to the next presenter.
I have a question.
Yes, Dr. Njoroge, please go ahead.
Thank you, Josephine, for such interesting work. Okay. I have two main questions.
Okay.
Number one,
Dr. Njoroge, thank you.
Yes, I'm making them brief. Number one, which tackles the introduction part of Josephine and the recommendation. He says, she says that inorganic fertilizer depressed soil productivity.
Inorganic.
And she expounds. Inorganic fertilizer depressed. And that's what you said even at the last recommendation. Well, as soil scientists, and considering the tropical soils, there's nothing that can grow without, application of nutrients, and mainly from inorganic fertilizer. We know we apply organic fertilizer, but its quality is variable, and actually in tropics it is very low. So eluding that inorganic fertilizer depresses soil productivity, it gives me concern as a soil scientist.
Yeah, actually, as soil scientists, in fact, soil is part of our livelihood. And looking at the status as it is, we are having the depleted scenario of our soils because of long-term cropping and introduction of the inorganic fertilizers within our soils. You will find that many work has been done to prove that continuous application of inorganic fertilizers, in the long run, they cause soil compaction, imbalances, and we have got accumulation of other nutrients that maybe are never known. And such like things may lead to toxicities, because as much as like DAP, we are only concerned about the P, but other nutrients within it, impurities like the heavy metals, we don't know about them. But over time, as we overload our soils with these extraneous inputs, eventually we are depressing the yields, because every year you have to apply more, but very little is used. Much of it goes into spoiling the soil structure through compaction and imbalances, and in the long run, we are having no soil that is productive, because even the microorganisms are no longer there. And I think I'm very clear on that. I'm not mixing up myself. You continue using organic fertilizers without organics, we are killing our soils.
Thank you, Josephine. Dr. Njoroge, you said you had two. That is one.
Yeah, thank you, Josephine. But in the first question, I wish Josephine could have some facts rather than saying without facts. I would go to the second question. She said, from her results, she said that there was increase in nitrogen, and she said it comes from Mavuno and farmyard. My question is, did she do farmyard analysis, and how much and did she apply from each and every sources of these fertilizers she used?
Actually, I did. I have got the results for the manures, but my recommendation were based on P levels, because I wonder how possible it is to use both sources and remain with the same rates. So I think my area of concentration was on P levels, not N. But given the results, the N levels accruing from the inputs were higher for the inputs as compared to the control.
Specifically, which amount?
Not specifically, but I'm saying that given that I'm only giving the averages under the inputs, but I said that I also had subplots with
anyway, I rest my case.
Josephine, you're muted. Thank you.
Chair,
Thank you,
I rest my
Daktari.
case.
I think you can
just need to, I will interact with her later.
Yeah, please kindly interact at the department level so that you can be able to get these questions answered.
Yes.
Dr. Rachoni, just very fast before we move to the next presenter, please, because I thought you had a question.
Yeah, mine is very fast. Thank you, Chair. Yeah. I just wanted to find out from the presenter what she meant by split plot, because I don't see what was split, what was the main plot, and what were the subplots. If she can quickly tell us about that, I will really appreciate. Thank you.
Yeah, looking at my layout, when you go to the slides under methodology, you'll find that the main plots were formed by the fertilizer inputs, that is control, farmyard manure, mavuno, and the combination. And when you come down to the subplots, you find that there are the intercrops there that are majorly legumes. So it was a split plot in randomized complete block design.
Thank you, Josephine. Yeah, so let us just go to the next presenter. Although I had a very, as the next presenter is loading, just a very quick one, Josephine. Yes. You alluded to the fact that mavuno fertilizer affects soil pH, it increases soil pH, if I heard correctly. I'm just curious to know what is the mechanism that this mavuno fertilizer will actually increase pH, considering the fact that you know that when you are dealing with soil acidity, actually it is the three anions, the hydroxyl carbonate or bicarbonate, that actually is used to neutralize the acidity. What mechanism is the mavuno fertilizer? You know, the processes that are happening in the soil that actually contribute to the increase in pH. A very quick one on that, and then we'll go to the next presenter.
I think it is a replacement of the calcium cation on the exchange site, and I think it is hydrolysis. I think the chemistry is a bit lengthy.
Thank you, Josephine. Okay, thank you. Let's appreciate Josephine. We go to the next presenter. The next presenter is Philip. Philip, are you ready?
Yes, I am ready.
Please go ahead. Take the shortest time possible. And please, if you're not presenting, could you kindly mute your microphone? If you're not presenting, kindly mute your microphone. Josephine, please mute your microphone so that you can allow the next presenter to present. Josephine, kindly mute your microphone. Thank you. Go ahead, Philip.
Thank you. I'm presenting on factors affecting days opiums among these smallholder dairy farmers in Uasin Gishu County. The paper written by Philip, but my supervisors are Dr. Omega, Joseph, and Dr. Kios. Let's go to the next slide, introduction. Dairy farming is the single largest subsector of agriculture in Kenya, which contributes 14% of the agricultural GDP, and with annual growth of 4.1%. Smallholder dairy farmers contribute 80% of all the total milk being produced, and also account 56% of the milk produced in Kenya. The majority of farmers are smallholders, which are 70% in Uasin Gishu, and also I think that's a picture which is in the country. The demand for dairy products is continuously increasing. To meet this demand or this need demand, a good or appropriate breeding technology needs to be done, and also to gauge out of this, the indicator for a good dairy breeding is day open and calving intervals. The next slide, please. Next slide, please. Statement of the problem. The dairy subsector is one of the economic importance in Uasin Gishu County. Uasin Gishu being the dairy county, so the dairy sector is of economic importance. So the factors that influence extent of days open, that's a days open is the day from when the animal comes down until the day the animal comes on it and being served and conceived. And also, I think that the county of Uasin Gishu is carrying out a subsidized program, which is AI scheme. So the low uptake of AI has also given us a statement. These are the main problem that we have to carry out this research. Next slide, please. Justification. The small dairy production make up 80% of the total dairy producers and 56% of the milk produced in Kenya and 70% of the total milk marketed. So smallholder dairy farmers play a key role in economic of the county and also the country. The demand for milk, and its products are on the increase due to the ever rising human population, also the change of land use, and also I think that there are also the preference for proteins and the proteins. Also, we have seen that the appropriate method of breeding is artificial insemination. So we need a suitable technology. We need to make it to use it appropriately. And also there's need for the factors influencing days open be identified and adoption or mitigation steps recommended to make use of breeding or artificial insemination technology sustainable. Next step. Next slide, please. General objective. The main general objective is to identify factors that influence the reproductive and productive potential of a dairy cattle among smallholder dairy farmers in Uasin Gishu. Next slide. The specific objectives. We have two. One is to determine the extent of days open among smallholder dairy farmers in Uasin Gishu, and two, to assess the factors that influence days open among smallholder dairy farmers in Uasin Gishu. Next. Materials and method. Study area. Study areas is done in Uasin Gishu County. Uasin Gishu County has 3 agroecological zones. That's Upper Highland, Mid Highland, and Lower Highland. From the Upper Highland comprises of areas around Nainapoi, Ban Forest area, Mid Highland around areas around Eldoret, and also Kapseret area, and Lower Highland is around Moiben and Lower Ziwa. The average population of Uasin Gishu is approximately 1.2 as per the census 2019, and also receive annual rainfall of that. The next slide, please. Target population. The target population that we are using are smallholder dairy farmers. The target population were smallholder dairy farmers in Uasin Gishu who are well distributed in the 3 agroecological zones. And also the area that we are using were 2 dairy cooperatives in which were registered with the Uasin Gishu County cooperative offices, which we were using 2 per agroecological zones. The farmers also that were used, the farmers that were targeted were farmers that are the members, active members of the societies, which were evidenced by the daily milk delivery records at dairy cooperatives. And also the farmers that were also selected, they were also the farmers which were also keeping the animals and also not keeping the mature bulls. Materials and method. Study area. The study design. 216 smallholder dairy cattle in the 3 agroecological zones were purposely selected. A farm was considered to be a smaller dairy farmer if it has 1 to 10 animals, heads of animals. And also we use purposely selected 6 active cooperatives in the 2 agroecological zones. So focus group discussions and descriptive cross-sectional survey were used. Continue. Next slide. Cattle selection. in each agroecological zones, the first 24 animals to come, of which of the 3 predominant breeds, that's the Frisian, Asia, and Zebu, to come on it were purposely selected, of which it was 72 Frisian, 72 Asia, and 72 Zebu crosses, coming to total to 216 animals. Type of semen that were used were conventional imported semen, conventional semen, Kenya genetics semen that is from Kagrik, and sex-sorted semen. Prevailing term, because it was on-farm experiment, all on-farm conditions were not altered. That's feeding, housing, sex preference, and general managements were not altered. Next slide. Data analysis. Data generated from the animals were entered into Microsoft Excel worksheet and analyzed. Data of days open, that is days from calving to first artificial insemination and conception, were obtained from 116 animals. As I said, 216 animals were selected, but when we analyzed, we only got on 116. The other 100 were not having any good records. Either they were being bought, or even farmers were, most of them were brought brought in the farm, so they were not having any records to know when there was the last calving. So it was punched out. The data was subjected to independent two-sample t-test to establish significant difference within variable categories, that is zones, breedings, and farming system, farm system. Information from the focal groups were analyzed and presented descriptively. Next slide, please. Results. From our results, the mean days open for Uasin Gishu was 256 days, 255 days. From the zone 1, that's zone 1, it had 303 days. And zone 2 was 281 days. Zone 3 was 206 days. Overall, it was 256 days. That's the mean for Uasin Gishu. And Asha were having 264 days. Frisian 258 days, whereas Cruces was having the lowest with 244. In the terms of farming system, we realized that intensive farming was having a mean grade of days open of 227 days, whereas semi-intensive system was having 260. In terms of the animals that we did, because after doing insemination, we went to do BD, that's the main pregnancy diagnosis in the 50 to 60 days. We realized that the animals which were confirmed in calf were having 279 days as days open, and those which were negative, that's were not in calf, were having 237 days as their days open. Next slide, please. From the focal group, we had 42 participants from the six dairy cooperatives that were engaged in the focal group discussion. That is, we had 4 to 6 members in every focal group. Most of the laborers that we realized that 61% were carried out by the farmers themselves, and mostly were women. And then the rest, 39%, hired the personnel. Most of the farmers that were laborers were women, and very few youths participated. Only about 20% of the farm handlers, that is the workers or laborers that were engaged, had a formal skills that they can able to write and write, but mostly 80%, the others were unable to write and read and write. We realized also the farmers, most of the animals which are high producing, they were losing weight firstly in the first 100 days, which means they were well being taken care in the first 100 days in milk. That's the first day before and after calving down, they were not taken care of. And then we also realized that the area had very poor access to veterinary services and extension services. Next slide, please. In terms of marketing, because this one we realized that it's also a very big factor which affects days open. Realize that milk market price of milk and products were not stable. Realize that over over 80% felt that the price was deplorable, and then over 60%, over 50% realized that the price was fluctuating, which means they cannot make any standing in plan for their activity. Next slide, please. Also, we realized that because what has affected the days open were the incidence of diseases.
Philip,
and the major one were tick-borne diseases. Realize that animals which are affected by tick-borne diseases, they usually come down after coming down with tick-borne diseases. Recovering took long, so which means they extend the days open. So the major diseases were East Coast fever, anaplasma, mastitis, and high condition, which were also affecting the days open. Continue. From our research, it shows that having intervals which is coming together with days open, we realize that only few farmers which were having the recommended days open of 85 days to 100 days would get only 10%, whereas 90% were unable to get this 85 to 100 days, which is days of recommended days open. Continue discussion. The overall days open was in Gishu is 255 days, which means, and on average, on others, the range were, the lowest one we got was 44 days, whereas the highest was 768 days, which is almost over 2 years. And it was so expensive for farmers to maintain an animal for over 200 days, which is unproductive, because the animals are productive, milk productive period for animals is almost 9 months. That's 303 or 3 days. That's the range. But above that one, it became uneconomical. The factors that influenced days open that we realized was one was poor management, especially in the first 100 days after milk.
Philip, kindly wind up, please. Thank you.
Yes. The second one was high incidence of tick-borne diseases, insufficient number of veterinary services, insufficient record keeping. As were the herdsmen that were employed were not having a sufficient, were not well educated. They were unable to write and speak. That's why they were not able to keep records. And then the decision making, that we realized that men were the one making decision making, but most people who are taking care of the animals were women. So they were really having to making decision. Conclusion. Next slide, please. Conclusion. Yeah, that the average days open was in usually 255 days, which is about way above the recommended days of 85 to 100 days.
Philip, please wind up.
The animal and farm factor that influence or affect days open are breeds, as we see that crosses were having the lowest breeding, low days open. Agroecological sources are affected, and also the farming system. Sable crosses, as you had seen, it was having the lowest days open. Next slide, please continue. The high incidence of tick-borne diseases also influence days open, and also the prevailing market condition also influence the days open. And also, as we can see, also the intensive farming system was having better days open than semi-intensive system. And also from our pregnant diagnosis that we did, we realized that only our Singishu had 48.2%. That is conception rate for Wasingishu, which means Wasingishu needed to use 2.1 straws for any insemination for AI. Thank you.
Thank you, Philip. Because of time, I really want to have all the presentations made. So I'm going to ask Eric to present, and then finally Susan. Then you can have the question later. Thank you, Eric. Please, Susan. Then you can have the question. Thank you. If you're not talking, please mute. Mute.
Sorry, I'm seated with my supervisor. Maybe
Eric, are you using two devices, because there's a lot of noise coming from your end? Eric, are you using two devices?
Okay, I'm muting one.
Let me allow Eric to present from my computer.
Eric, go ahead.
Load the slides, please.
Yeah, good afternoon to you all. My name is Eric Misiko Manuya. I want to present a study that I have done with the title Assessment of Growth and Survival Performance, Challenges and Opportunities of Raising Improved Indigenous Chicken Using Sorghum-based Rations in the drylands of Western Kenya. This was done in collaboration with Dr. Achuonyo, Professor Were, Professor Gudu, and Professor Nyangweso. On my introduction, please move to the next. The drylands normally experience a lot of food insecurity due to low crop and livestock yields. And this has also increased poverty levels. However, we know that some crops like sorghum are drought tolerant and can do well in such places. Indigenous chicken also do well in such areas because they have good adaptation in these areas, and they also require small spaces, low input, and also not very skilled management practices, and quick returns to investment, and also a ready market for its products, that is meat and eggs. Sorghum can also be adopted as a source of energy in homemade rations for the chicken. On my problem statement is that chicken productivity is negatively affected in many places, including the drylands of Western Kenya, by low, rather unreliable quality and quantity feed resources. Most of the conventional feeds are maize-based, and many times they are expensive because of competition between human food and animal feed that maize is used for. We need also to explore an alternative feed resources that can replace maize, so that to mitigate the idea of maize-based feeds being expensive. However, sorghum has got a problem of tannins, and also it has a low commercialized production level. On my justification, chicken production is attractive to the rural households due to their good adaptation, and is an important source of food, of high value protein, that is meat and eggs, manure, and also quick cash. Sorghum, being a grain similar to maize, can also be used as a feed resource in homemade rations because it's locally available and it is low in cost of production compared to maize. On my objectives, my broad objective was to determine the response of improved kienyeji chicken fed on the sorghum-based rations and the dynamics of rearing it in the drylands of Western Kenya. The specific objectives were to assess the growth and survival of the same chicken distributed to farmers, and also to assess any challenges they could be having, any opportunities that we could take advantage of as they keep this improved indigenous chicken. On my materials and methods, the field study was done in 5 wards of Ugenya and Busia counties, 2 sub-counties, that is, Ugenya and Matayo sub-counties of Siaya and Busia counties, in areas considered to be dry lands. 50 farmers were purposefully selected and mobilized 10 per ward. and each was provided with the aid of the improved indigenous chicken, whose growth and survival was assessed on a bi-monthly basis. Farmer selection was based on previous experience with poultry and sorghum production, willingness to be trained, ability to keep records and to monitor flock performance, participation in a training on how to formulate homemade rations. That is, farmers were chosen after participating in that training. Next, please. The selected farmers were monitored. Their chicken were monitored, including the 8 that they were given. So we monitored the weight gain and the growth of the chicken and also the survival rate. Other records included some of the strategies that they use normally for breeding, for housing, for disease control, cock replacement, flock turnover and marketing strategies. And then also we looked at how much do they eat the eggs and the meat from the chicken. And then the gender roles that are involved in managing this chicken. This was done using a structured questionnaire, particularly for the other questions that didn't need measurements. Next, please. Data analysis was done using SPSS Statistical Package version 17 to establish any significant differences. And the gross margin analysis of the diets was calculated using prevailing market prices and costs of production, the target area. Next, please. There you can see some of the pictures as we were training farmers, distributing the chicken, and also some of the farmers, how they were keeping the chicken in their homes. Some of them were in the open, that is the free range, and others were confining in their houses or in some structures that they had put up. Let's go to the results, please. Sorry, just move on. That was a mistake. Move on, please. Those two are not supposed to be here. And on common production systems or housing systems, most farmers keep their chicken in free range, that is 65%. They prefer it because it's cheaper. It does not involve so much because you just get your chicken and after you release them in the morning, you just wait for them again in the evening. But around 35% practiced confinement. Around 10% practiced semi-free range. That is, they release the chicken, but they don't go outside to the open environment, but it's an enclosed environment. Maybe within, and some of them were just doing it within their compound. Next, please. On the varieties of sorghum that these farmers were using for feeding the chicken, we realized that most of them were using a sorghum variety called Nyadundo. We had the others, another one, E1 and C26 were the most commonly used by the farmers. The others were not very commonly used, either because they were not available on the farm or they were not available on the market. So that was one thing that was limiting the use of sorghum. As you realize, I said that sorghum normally has a problem of tannins. So most of the sorghum that farmers are using is high tannin, but it's because it has been, they have grown it for a long time. It's cultural. And so sometimes to change them takes time, but that's how it was in the field. Next, please.
Very kindly wind up, please.
Okay. On the cost of the homemade rations, as you can see in this table, the more sorghum that was added in the feeds, because most of them were having a ratio of maize and sorghum, the more sorghum was added, the cheaper the feed became. Of course, they were adding other things like omena, soybean, and ochonga, which other people call omena dust. Next, please. As you can see, the weight gains of the chicken that we gave to the farmers compared so well with the chicken that were raised on 100% maize, and also with the chicken that we did an experiment, an on-station experiment. The farmers' birds' weight gain was quite comparable to what we did and also to the maize. So we concluded that sorghum can still do as well as maize. Next, please. The graph here just shows the farmer who performed so well and the farmer who performed badly, and then the average that we got from the on-station experiment that the farmers didn't do very badly. Next, please. Generally, as you can see, most of the farmers who are raising the chicken were female, and those that were raised by female did very well. And most farmers also used sorghum and maize at 90%. 78% use what is on the farm, 68% use what is on the market. And most farmers mix at a ratio of 1:1, that is maize and sorghum. Then also most farmers preferred the improved kienyeji or indigenous chicken at 94%. Next, please. And then also most birds gained a weight of over 1,500 grams, which was good for the market. And most of the free-range birds performed poorly in terms of weight gain, but the confined ones performed better at 75%, gaining over 1,500 grams. We also realized 80% of the interviewees, they love chicken and eggs, and most of the birds also survived during the survey. So in conclusion, next please. In conclusion, is that sorghum-based feeds are marginally cheaper than maize-based feeds. They are popular with the farmers, and they perform as well as maize-based diets. And therefore, I recommend that rearing, or rather in conclusion, that we can rear this improved indigenous chicken on sorghum-based diets. It is feasible. And this was observed because of the favorable growth performance, low mortality rate, and also high preference rate by the farmers, particularly of the female gender. And this can help us to enhance food security in the drylands of Western Kenya. My recommendations is that more farmers should grow the low-turning sorghum to ensure enough volumes for sorghum-based feed processing, and also that there should be more training to improve on productivity, because most farmers are still using traditional methods. Thank you.
Thank you. Thank you very much, Eric, for your good presentation. Please allow me to ask Susan to present, and then we can take questions up thereafter. Susan? Susan? Kindly present.
Okay. Good afternoon. Good evening. Is it afternoon?
Good afternoon.
Can you hear me?
Yes, we can hear you very well.
You can hear me?
Yes, we are trying to upload your slides.
Okay.
Okay, Susan, go ahead, please. Your slides
Thank
are
you.
uploaded. Yeah.
Thank you. Good afternoon.
Please
everyone.
make it very fast, Susan, kindly.
I'll try
Sorry to rush you through. Yeah, thank you.
Okay, give me my slides. The first slide.
They're there.
The second one, gone. Okay, I'm presenting on effect of supplementary feeding with soybean fortified porridges on nutritional status of preschool children. These are 4 to 5 years old from Busia County. Kenya. Let me point out that this is just a section of my PhD study that I'm currently doing, and this is just one of the objectives. So the questions might arise of this and this, but there are many analyses that have been done. Go on. Next slide. Okay. So this is, the study was done to counteract on the effect, to find if there is a way that we can be able to reduce the malnutrition among the other 5. Since we know the undernutrition is a major nutrition problem in the third world countries, and the major nutrition problem is PEM, which is affecting many children under 5 years, and it's the worst form of malnutrition, and it's a risk factor to so many illnesses, and actually causes magnitude of deaths among children in developing countries. Next slide. So in Kenya, according to KDHS, Kenya Demographic Health Survey of 2015, it shows us that we are yet far much below the recommended malnutrition rate, which should be based on our vision 2030, we should be talking about 5% malnutrition rate, and now we can still see the stunting, the underweight, and wasting are still high according to that research. And the research that was done by JERA 2016 still indicates in Busia the 3 malnutrition cases, indices are still high. That is 13.3, 14.8, and 15.5. This is stunting, wasting, and underweight. Next slide. The immediate cause of undernutrition is inadequate diet and diseases. However, there are many other underlying causes that actually influence the households on what their diet is going to be like. And since most of the households in developing countries live below $1 a day, they are unable to utilize diversified diets, and hence they rely extensively on staple cereals and roots and tubers to feed their infants and young children, hence contributing to the magnitude of the high malnutrition rate. Next slide. However, though these are the extensively used foods, these are the roots, tubers, and cereals, since they are used without proper fortification, it is known that combining these cereals with the legumes and other multi-micronutrient premix and protein concentrates can actually be used to prepare a composite that can be used to feed the infants and adequately used for complementary feeding. Next slide. For instance, since porridge is popular winning and supplement diet for school-going children and currently being used in most school feeding programs in Kenya, compositing cereals with adequate amount of legumes will compensate for the limiting levels of essential amino acids, which are actually lacking in cereals. Next slide. Therefore, this study, which now formed the basis of objective of this study, is that we formulated four blends of flours using maize, sorghum, and soybean. Since they are in our preliminary or baseline studies, we found that they were widely grown and utilized in Busia and specifically that sub-county Matayos, where we carried out our studies, and hence we used the materials that the communities were using in their children diets and also for grown-up to formulate a composite that was nutrient dense, and thereafter we used these formulated diets to do a feeding trial in the preschool in Igero Primary School. Next slide. So these are baseline findings that are unpublished from the focus group that we carried out in Matayos sub-county with the farmers revealed that most porridges prepared and consumed in their households were blends of just maize, sorghum, millet, and cassava, which now you can see all these are cereals and they are dense in carbohydrate and energy only. Therefore, through feeding tray study, parents were sensitized on complementation of sorghum and maize with soybean in making porridge flour blends for their children. Next slide. So the materials that were used then were sorghum, that was red brown, soybean, which were purchased from Matayos market in Busia, while maize was purchased from University of Eldoret, Eldoret farm. Next slide. Feeding center, Igero Primary in Matayo sub-county, Busia, Kenya was used. Why was this selected? In Matayo sub-county, the prevalence of wasting, underweight, and stunting among children aged 48 to 59 months stood at that time, that is 21%, 0.2, respectively. Next slide. Another reason is that it had a high enrollment data from Department of Education and Vocational Training of Busia, that is also unpublished, showed that among the 51 registered ECD centers in Matayo sub-county, Igero ECD center had the highest, and hence it would give us the sample size that we needed. The school had also adopted provision of maize porridge at 10 o'clock among preschool children. Next slide. The grains preparation and flour formulation. I'm not going to go into details of optimization and formulation because it's as length and it's another objective, but after optimization and formulation with the ingredients that are pointed there area, using the prescribed and scientifically approved method of preparation of those materials, we came up with we took the 4 formulation to the trial study. Why I'm saying this, I'm not going to details of optimization and formulation is because there were many, we did the 12 formulations, but here we are only interested with the 4 that we used to feed our children in Igero Primary School. Next slide. The 4 types of flours that we took to the feeding trial was first, the 100% maize flour. Why was this? Because it's the one that the Igero school were using even before we went to do the trial to feed the children, which now formed as our control, and that which had 70% maize and soybean that percent. The third formulation was sorghum 70% and soybean that percent, and the fourth is had sorghum 45%, 45% maize and soy 30%. So we
Nakumbuka siku ya kwanza ndio kusimama tu. Our chief guest, who is our DVC Research and Extension, our Director of Research and Innovation, our professors present, other directors, my colleagues, the rapporteurs, ladies and gentlemen, good afternoon. Good afternoon again. Now, there is an old Chinese saying that goes that there is no never-ending feast. If any feast must come to an end. And indeed, we have come to an end. It has been a great 3 days that we have been in this conference, whose theme was Towards Food and Nutrition Security, Challenges and Opportunities. At the opening session, I said that I hoped we would learn new ideas from each other, which we would adopt to further improve our food and nutrition security in Kenya and globally. I believe the many good experiences we have shared today in the past 3 days have been great lessons to us. We learned from amazing keynote speakers who gave us amazing keynote addresses. We learned from research participants who gave great ideas out of their research. And in total, we had 97 speakers. This is really a great achievement. Now, during these 3 days, we have learned that there is a possibility to improve the food security situation in our country and globally as well, because we have identified opportunities that are available and even the challenges that are available. So we need to get out of this and use these challenges and opportunities to try and alleviate the food insecurity situation in our country and globally. I would like to thank all delegates who joined this conference via Zoom and those who followed it on YouTube. I sincerely hope that your presentations and discussions and all of us who contributed to solving food security issues in our communities and the nation at large are going to be implemented in our policies throughout our country. Ladies and gentlemen, although this is the last day of the conference process has not ended. There are still some few steps that we have to take to be able to take our journey to completion. Therefore, we are going to send you a format that you're going to use to write your full papers, submit them for peer review, and those that will be eligible are going to be published in one of our university journals. So this publication may vary from one journal to another. We request that you be patient even as you submit your manuscripts. I would also like to take this opportunity to thank the Directorate of ICT of University of Eldoret. They've made this virtual conference a great experience. I would also like to thank our able rapporteurs for doing a job and making sure that the presentations were so smooth. Thank you so much, and I believe you've learned quite a bit. And next time, you'll be the ones presenting and not rapporteuring. Thank you so much for all of us for all the work you've done today. And at this moment, I want to invite the Director of Research and Innovation to invite our chief guest so that you can have the closing remarks. Thank you.
Good evening once again. I wish to take this opportunity to invite our Deputy Vice Chancellor, Planning, Research and Extension, to give his remarks. Welcome, Professor Abul. Karibu.
Ladies and gentlemen, good evening. I am so pleased to stand here at the conclusion of this conference because it marks a journey that is very significant to us as the University of Eldoret, and particularly the Division of Planning, Research and Extension. This conference is one of the conferences that are there in our program. So we purpose to have at least 2 conferences every year. Last year it was not possible, we only had one on wetlands. And this year we have this on food security and another one from chemistry. And possibly there'll be a third from postgraduate students. Now, these activities are very important, as I emphasized in our opening remarks, that according to our quality objectives, the university is supposed to disseminate at least 40% of their research findings to the stakeholders. And so this conference is offering that kind of undertaking that we have made to do at least every year. Allow me, before I say anything else, also to thank the chair and the entire planning committee. Now, when we were starting this, I appointed somebody to chair. That somebody apparently did not start the chairing for almost 2 months. Then I decided now to dictate and appointed somebody who was Dr. Florence Wamunga, because I knew with him she will have to obey me. And I did not, I only gave him the topic and I did not tell her anything because I thought it's a good learning process because all these things are part of learning. And I wanted to see how a lady can organize, can spearhead the organization of a conference at the university. And I want to thank you, Dr. That's a good work well done, and the entire team that have been working together with her in this committee. And all, according to me, has gone well, including the ICT department who have been supporting this. Ladies and gentlemen, it gives me a lot of pleasure also because of the response that we got in this conference. We had about 97 papers, as you have been told, which have been presented in this conference, which is a very good number of papers. And not easy to get because research is not an easy thing. So I want to thank all those people who presented those 97 papers, which falls in about 7 thematic areas. We are also grateful to the several institutions who joined us. Apart from the 69 presenters from the University of Eldoret, we were privileged to have participation from the international community, from Chiang Mai University. I don't know whether that is China or Japan. That is China. Thailand. Okay. I thought Uchudo will call it Thailand. Okay, we also had Naro, Uganda was represented. Then we had the Federal University of Technology from Nigeria. We also had Hawassa University from Ethiopia. And so those who are representatives of the international community, I'm sure there are maybe others. So we want to be happy that this has happened. And also our local institutions. We had being represented here Moi University, Bomet University, JUST, MUST, Eldoret Polytechnic, Masai Mara, Maseno University, JKUAT, Egerton University. We had Kenya Marine and Fisheries Research Institute. We had Osingishu Veterinary Services, Crop Research Institute, International Maize and Wheat Improvement Center, Ministry of Livestock and Fisheries, Nakuru County, amongst others, which shows that at least the participation is both national and international. And we are very proud of the organizers for what you have done and what has come to pass right now. Ladies and gentlemen, the significance of food and nutritional security cannot be overemphasized. And I think this fact was highlighted very well by our Vice Chancellor, who gave the official opening ceremony. Her speech was very detailed, and for those of us who heard, it really set the stage for what we have been discussing the last 3 days. This was further expounded by our able keynote speakers, who have also done a very good job to try and open our horizon on the issues that were ahead of us. Ladies and gentlemen, also allow me to express also my gratitude in the achievement of the objectives of this conference. As I did say, that the results of what we carry out, we must disseminate. And the university has been in the forefront in disseminating information, particularly from work done in agriculture through our agribusiness trade fair. And we have a duty to the society because we are, as our university, which is based here in the North Rift, with a very strong School of Agriculture and Biotechnology. From where I sit, the bulk of the research activities going on at the university comes from the School of Agriculture, followed by the School of Natural Resource Management. And we are really proud of the School of Agriculture for the work that you are doing, and we would like you to continue doing that work because there are some people who are coming behind and they are going to overtake you very soon, the way I see, if we sleep. So I hope that there will be no sleeping, but it is good because of that kind of exposure, and we have enjoyed that exposure like when we organize agribusiness and we visit institutions in the country. There is nowhere you will reach or any county you'll reach without any of our alumni, which makes us proud that we are doing a good job. When you go to fisheries, it's the same thing. Each and every county within the whole country of Kenya, even crisscrossing over to Uganda, you must find an alumni of the University of Eldoret who are working on food security. The number of research projects that we also have at the university, at the division, the bulk of them are also addressing this. And that informed the reason why we chose this topic, because we felt there's a lot of research going on in food and nutritional security at the university. And so this should be the best way, or rather the best topic to at least be one of the pioneer conferences that we are going to have. So thank you so much, School of Agriculture, for making us proud and all the other people who have participated in this. Now, to conclude, we are concluding the conference today. And just as has been said by the chair of the planning committee, the work has just begun for the committee. So don't think that you have ended the work. You have just started the work. In the sense that we are disseminating, apart from the oral dissemination that we have done in the last 3 days, we now remain with the dissemination on printed material. And so you have to remain together as a committee and work as a team. Because from the division, we would like to see from you, the chair was saying that you have to be patient. Chair, we are not going to be patient because this output, we must have it as soon as possible. Let everybody, if you get any communication from the planning committee, to respond very quickly. Because you must give us a publication of the proceedings, which is going to help several people who maybe didn't attend this conference. Number 2, you must publish the quality selected papers that were presented here in a special issue of the journals, which you are going to choose as a committee. If you'd like to do it in our local journal, well and good. If you'd like to do it in one journal that you can negotiate with so that they can have the papers on a special issue, that is well and good. And this requires that the committee must remain together, particularly the scientific committee, subcommittee, so that you can be able to continue reviewing and making sure that we have quality papers being published as an outcome of this conference. Last but not least, you also have an opportunity to publish a book. If you look at the status of food security in the country, from the thematic areas, you've got so many presentations. If you can sit down well as the scientific committee, you can easily delineate different areas and match some of the presenters to give you different chapters. So at the end of it, we are going to, you can come up with a good book that is going to help us, to also help the nation to understand and to know the work that we are doing at the University of Eldoret, along with all our partners from the different institutions. I think that is what I really would like to say as we end this conference. I am very excited, and I want to thank everybody, including our senior professors who are also giving guidance and also brought us so many students and young researchers they are working with, like Professor Julius Wichudo. We highly appreciate Professor Miriam Kinyua and several others. We really appreciate the kind of work that you are doing and that you are assisting the university as it comes to these issues to do with research. So ladies and gentlemen, with those many remarks, I want to stop there and to thank you so much. And as we go, as we leave, let us leave, but let us not forget the things that we have discussed here. I really wanted to be here throughout. I could not be because of other issues, but for today, I'm going home a very happy person because I've learned quite a lot on some of the things that I've never heard before, or I've never known before, or I knew, but I never knew them in the kind of details in which they are. So thank you so much. May God bless you. God bless Kenya. God bless University of Eldoret.
DVC, ladies and gentlemen, I must say I'm honored and privileged to give a vote of thanks to all the participants of University of Eldoret 2022 conference. The Food Security Organizing Committee, led by our able chair, Dr. Florence Wamunga, thank you for the good work done. The Office of DVC for the support and guidance. The VC, University of Eldoret, for agreeing to be our chief guest of honor. Our keynote speakers, Peter Kioko, Paul Kimurto, and Dr. Barasa, our scientist, who came in handy at the last minute. We had also parallel session chairs who really supported this work, and everything went smoothly. The rapporteurs who were behind doing very useful work. The virtual conference would not have succeeded without our ICT. I will not forget to thank the Secretariat, who worked day and night to compile our abstracts and the program. I am made to understand that a number of followers were in YouTube, Facebook, and Twitter. I want to appreciate all those that participated. As I end, I encourage all participants, as has been said by our DVC, to publish their work, especially for this conference, in reputable journals. Where possible, we are ready to support. Thank you, and God bless you. Who's going to clap for us?
Okay, we are waiting. Training them. Who are they? Who does that? No. It is campus. And now when they get these tires, they also have the tubes. They always cut the tube into strings. Then people use it for tying things on their bicycle, isn't it? So when the camera is pulling this plastic, you say kusia, isn't it? So you're going to kusia, then you water. Okay? Prof, Ochodo, this is school, kusia. Kusia, water. Okay, that's what you're going to do. So you're going to clap for ourselves first, because nobody's clapping for us, isn't it? So before you clap for others, you have to clap for ourselves. Okay, kusia, water. Kusia, water. Kusia, water. Thank you so much. So let's give a clap for our director first of all. The director will give him a different one, isn't it? It's going to be like the rain. The rain goes slowly, then it goes quickly, and then they stand. So. Okay, rain. The rain is falling. Slowly, slowly. More rain, more rain, more rain, more rain, more rain, more rain, more rain. Thunder. Thank you, Professor Chodo's point. And for the DPC, you're going to give him 5 factorial. Okay? Go. You will have figured these ones were born long after M1 died now and a bigger makofi ya nyayo. You pick 5 factorial is 5 claps, then 4 claps, then 3, 2, 1. Okay, let's start. Go. Thank you so much. So we have finished our conference. We started the national anthem. We will sing it. We will sing the national anthem. It won't be played. Let's rise up and sing the national anthem. Let's see how patriotic we are. Sima, we can sing or you're going to play for us? Okay. Mungu nguvu yetu, ilete baraka kwetu, haki iwe ngao na mlinzi, na tukae na undugu, amani na uhuru, raha tupate na ustawi. Director, close for us with the word of prayer, kindly.
And we close with the word of prayer. God, our Heavenly Father,
let us pray. Our Heavenly Father, we just want to thank you for having seen us through to the end of this conference, my Father. Thank you that from day one you have been with us. Thank you for all our guest speakers. Thank you for our keynote speakers. Thank you for our hosts, my Father. Thank you for the directorate and the division of research. Thank you for all the committee members, my Father. Thank you for all the work that has gone into making this conference a success. Thank you for the chairs of sessions. Thank you for rapporteurs. Thank you, Lord God, for our students and other participants from other institutions. Indeed, it could not have been the way it is if it weren't for all these people, my Father. And as we come to the end, we just want to thank you, to bless your name, and we continue to commit our institution, the University of Eldoret, into your hands, Lord, that you may continue to bless our institution, continue to bless our leadership, continue to bless even our country, Kenya, my God, which has allowed us to thrive in this nation as an institution of higher learning. We thank you for each one of us, and as we now close this session, we pray that you may go with us, and as we await for another conference, my Father, may you continue to help us and help even the team that is going to do the books, the proceedings and the journals, that Lord God, everything will come to a conclusive end to the glory and honor of your name. We pray this, believing and trusting in your name, Jesus Christ.
Amen. Thank you so much. We are done. Please go well home. Let's wait for the next food security conference. Thank you. Oh, group photo. Yeah, group photo.
The University of Eldoret is a modern university situated approximately 9 kilometers northeast of Eldoret town in Uasin Gishu County, Kenya. Founded in 1946 and converted to a teachers training college in 1984, in 1990 it became Chepkoilel campus of Moi University, offering natural, basic and applied science programs. In August 2010, the campus was upgraded to Chepkoilel University College, a constituent college of Moi University. Upon the award of charter by the President on 11th February 2013, the University College was renamed University of Eldoret. Our vision is a premier university that nurtures global leaders and innovators. Our mission is to provide quality education, training, research and consultancy in science, agriculture and technology to meet the needs and aspirations of a dynamic society. The University of Eldoret is ISO 9001:2015 Quality Management System certified. The university is led by the Chancellor Ambassador Professor Judith Mbula Bahemuka, who is the titular head of the university, the council comprising of the chairperson and members, and the University Management Board led by the Vice Chancellor Professor Teresa Akenga. The other members comprise of Deputy Vice Chancellor Academic and Student Affairs Professor Ruth Otunga, Deputy Vice Chancellor Administration and Finance Professor Wilson Ngetich, Deputy Vice Chancellor Planning, Research and Extension Professor Philip Raburu, the Registrar Academics Professor Paul Taruz, Acting Registrar Administration CPA Francis Ikapel, Registrar Planning Dr. Benjamin Mwasi, Acting Finance Officer CPA Ereu Totona, and Senior Legal Officer Mr. Stephen Anditi. University of Eldoret is science, agriculture and technology based and has grown steadily from the initial schools of forestry and science to the current 9 schools with 34 academic departments. The schools are led by a team of deans who also provide academic leadership and management of the faculty. They include Dr. Oliver Kiplagat, Acting Dean, School of Agriculture and Biotechnology, Professor Robert Otuya, Dean, School of Business and Management Sciences, Dr. Paul Odwori, Dean, School of Economics, Professor Kisilu Kitainge, Dean, School of Education, Dr. Julius Kolongei, Dean, School of Engineering, Professor Gelas Simiyu, Dean, School of Environmental Studies, Dr. Jacob Onyango, Acting Dean, School of Human Resource Development, Professor Boaz Kaunda Arara, Dean, School of Natural Resource Management, Professor Samuel Luta, Dean, School of Science, and the Dean of Students, Dr. Lelei Kiboi.
This is one of the big schools in the University of Eldoret with several programs covering all the fields in agriculture, both at undergraduate level and postgraduate level. Also, we have some diploma programs. We strive to be a center of excellence in agriculture, as our vision is to be a center of excellence locally and globally in agricultural sciences, technology development, and transfer. We have a total of 6 departments within the school, which are under the dean. So we have a wide range of courses, and our students are not limited to work in agriculture, although most of them work in agriculture, but we have other options which are not traditionally agricultural enterprises, but nowadays employ our students.
The School of Education is the largest school at the University of Eldoret. We serve about 50% of the total student population. The school is housed at the main campus in the education complex and also at the town campus located at Musco Towers opposite Sirikwa Hotel, Eldoret town. The School of Education is organized in 8 departments. We at the School of Education prepare teachers and trainers to be employed by the Teachers Service Commission and the Public Service for Technical and Vocational Education teachers. Our graduates go into industry and private practice. The School of Education programs are highly popular due to the many avenues for employment after undertaking the courses. Graduates can go into teaching, they can go into industry for technology education, and also some establish their own businesses.
The School of Engineering. The School of Engineering was founded in 2011 with 3 departments which are fully accredited by Engineers Board of Kenya. The first department is Agricultural and Biosystems Engineering. The second department is Civil and Structural Engineering. And the third department is Mechanical and Production Engineering. All the above 3 programs ran for 5 years. The School of Engineering has actually a number of unique strengths. The first one is that we have qualified and dedicated staff with varied experiences in different fields of engineering. Secondly, our programs are marketable, both at graduate and undergraduate level. We also have excellent teamwork among academic and technical support staff and also with students. We also have good cooperation and networks with neighboring institutions, industries, and other stakeholders. Without also forgetting, we are also located in a serene environment next to a fast-growing city. The School of Engineering has 4 administrative units. Mainly, apart from the 3 departments I have mentioned, we also have the school, the Dean's Office.
am Professor Samuel Luther, Dean, School of Science, and an Associate Professor of Chemistry. We have a mission and vision. Our vision is to be a vibrant center in excellence in generation of scientific knowledge. And our mission is to create, innovate, disseminate scientific information through quality teaching and research. As a school, we have 4 departments, namely Department of Chemistry and Biochemistry, Department of Physics, Department of Mathematics and Computer Science, and Department of Biological Sciences. We offer programs both in pure and applied sciences, and our programs are market-driven and sensitive to global trends in terms of